Previous class, we start with data, talk about definitions of data and why data labeling is important and what challenges it could be imposed. Now, the first thing we're going to talk about is that obtaining more data or obtaining data in general for your project. Series of you also have asked that questions on about the data that you are trying to find for your project. Okay. Now, the first is a question, and this exists in any company that you go and you work for. It's like how much time we should spend to get data, right? Lots of time you are assigned to a project, and the first question is, okay, we don't have data, we need to collect data, and you come up with the timeline and say, okay, I'm going to spend this much time finding data. And lots of time that answer is kind of like out of nowhere. It's just kind of like an estimate that you think that's going to spend time to gather data. But instead of doing that, you need to ask the question differently. You should, instead of basically saying that how much time is going to take, I'm going to gather, I need this much time to gather this much data for this project. You need to actually ask the question like, how much time do you need to gather this much data? Oh, sorry, in this much time, how much data you can get, and iterate from that. So that should be a loop, basically, that you quickly gather some data, iterate over it, and add more data instead of waiting for that perfect data to be collected. Because the more time you spend on the data, you just drag the project, and you never know you can actually have that data. So first thing first, collect the easiest data that you have. You can access it. Okay. Try with that. Maybe even with that data, you came up with an idea like, okay, you know what, this doesn't work. Instead of spending months' time or weeks' time finding the perfect data, spend a couple of days, 2 days, 3 days, find a data that represents the problem that you want to solve. See if that works, and then iteratively add more data to it. Now, the next thing here is that how often, how much data should I add? For example, let's say today you found the data, and in 3 days you want to find out. Basically, you have this loop that every 3 days we're going to add data. How much data should you add? Now, if you add lots of data, the problem is that you don't understand that. Like, let's say you have 3 categories, right? Cat, dog, a bird. And if you just go randomly collect 1 million records, you don't understand that which breeds of those animals in the picture are basically more important. They have a higher signal for your learning. So instead of just adding random data, large amount of data, add smaller amount of data, see the impact, and then iterate over that. So that should be the next thing for you. If you're doing a web sourcing, you crawl on internet and you try to get data for your LLM, instead of for you, because you're not a smaller team, instead of just trying to gather the entire web, target a certain portion, certain websites that you try to do crawling over, and then from there move. And next time, maybe go some. Let's say first time you pick the data for technology and you are doing some news, like LLM for news. Next time, instead of focusing on technology, focus on different section, and then move from there. Basically, you need to collect good data that has good signals also for your problem. Okay, so keep that in mind. And again, we will talk about the scoping. Now, in general, when it comes to data collection, companies have 4 options, basically. You either own the data, that means you have this customer base that they have been utilizing or using your services, doesn't matter which service. And this data has been coming in, doesn't have label or has label, we don't know that yet. So basically you own that data. And technically that costs you nothing because you own it. It's just a storage cost the company is paying for. The next one is a crowdsourcing. It's kind of like you can basically crawl on internet, for example, and gather data. That has a cost. The cost, you can account for the cost of engineers that they do that task and so on. You could pay for labels, basically. It's kind of like you have a data and you're like, doesn't have a label, so you pay to a company for labeling it for you. That's another option. And the last one is purchasing data. There are companies out there that they sell data for different, basically, domain. And companies like startups, especially when you want data, you just go purchase some amount of data and this will work. So these are like in general the 4 options that you have. Now, when it comes to labeling of the data, let's say you have a data, the company you work with, they already have a data. And you need to use it in some task, classification, regression, generation, whatever you do. The first question is that, okay, do we have label for it? No. How should we label it? Okay, so there are technically three options: in-house, outsource, crowdsource. Okay, so in-house, the term in-house basically is that when the team that you are working on, or the engineer team, depending on who's assigning this basically task, will be assigned to label data. Okay, is the worst part of the job that you have. If you are assigned that, you won't like it, but that's reality. Outsource is when you pay someone else to basically do the labeling. Okay, company has a budget and says that, okay, we have this much budget, and you basically do some up and down. See that, okay, if you pay Amazon, it's going to charge us this much. With this budget, how much data we can label. So if you know already how much data you can label, instead of just passing everything randomly to Amazon to label for you, maybe pick the data that you know is good, it's clean, it doesn't have noise, and label that. Now, when it comes to crowdsourcing, on the other end, it's like when you build a pipeline, and this pipeline comes from other existing tools in the market. Let's say there are some pre-trained models they are in the market. You cannot use those pre-trained models as part of your platform because they're expensive. But when you do research, the research team can use those models. So you use those models, some sort of like a hierarchical basically labeling, ensemble basically, you label that. So that's the idea of crowdsource, or you can basically search online if there is a label for certain type of data, you can also pick that up. But in general, having machine learning engineers label data is expensive, okay? And the reason it's important is that if at any point you are a team leader and you need to decide for labeling, keep in mind that you might, at first, it might sound like, okay, my engineers, they are free, they can basically label, but you shouldn't see it that way. You should say that, okay, how much per hour these engineers get paid? And that's the basically price that you are paying for labeling per hour. And think about that money, like an equivalent of that money could go to outsource somewhere, that is some company that does the labeling, and your engineer basically focus on what's more important for them. So that's something that keep in mind. Now, who's qualified for the labeling of the data? That's also different depending on the task that you did. Some tasks, they need type of raters that called generalists. Like, for example, if you are doing a speech recognition, you need someone that can understand English and they can basically listen and just transcribe it. But if you do like a factory inspection, medical imaging, and stuff like that, not anybody can do that. You need someone which is SME, subject matter expert. Okay, someone that is trained for that and they can do it. SMEs are by general, it's kind of like expensive. Like if you want to find a radiologist or a doctor to label data for you, it's not going to come cheap. So you need to account for that. And then let's say you have something like a recommendation system. Okay, but that over there is kind of like impossible to label that easily, right? What would you do? What's your opinion? But for the third one, you want to decide what should you recommend, who should you recommend? It becomes challenging, right? Because it doesn't matter if you have subject matter expert, it's basically based on the opinion what you should recommend. So task like that, it becomes basically difficult to label. And finally, don't increase data by more than 10 times, basically, 10x at a time. Don't just go over 1 million like the records and stuff like that. Now, the next thing is kind of like concept of data pipeline, but first we're going to talk about the organizing. So let's say you have basically you have a website, the column on the left, job board. Okay, that's a website. And there is an app for a resume. Okay, so you have users that basically use both websites, both the app and the website, but you're not sure if you're the same person or not. Why is important? Because if you know the person who's using the resume app to build the resume, you could, and you have seen the information on job board before, you can basically send them a kind of like a recommendation and say, okay, are you looking for a job or not? But in order to understand that, you need to have some pipeline for that able basically to do something like the user ID merging. Now, user ID merging always starts with something called spam cleanup, because you find lots of users on the website or on the app that they're kind of like a spam user. Not that they are a spammer, but they are just there to sign up and never use basically the website. So you need to first clean that and get rid of those. And then for the one that's are clean, you need to do user ID merge. And you need a script for that. You don't want to manually do that, okay? And then you pass that to some sort of like an ML model that predicts if someone looking for a job or not. Now, when we talk about this data pipelines in general, so during the development, you have this data from website, you have the data from apps, and you have this pre-processing scripts, which does the data de-spamming, it does the user ID merge, basically clean the data, and has it ready basically for the ML model that you have. Now, the importance here is that when you go to production, the same exact pipeline should be used during production, not an equivalent, not a translation from one language to another language. That's common in practice to happen. I personally worked in a company for 6-7 years. We were only developing in Python. Our development was in C++. So whatever we were developing, we used to go to a different team, they convert it to a C++ equivalent, and then they use it. The challenge is that whatever you use in Python, especially if you are using libraries, you don't have the equivalent in C++, right? So it won't be apple to apple. You always will have discrepancies between the basically data pre-processing that happens in Python versus C++, right? So you will have issues like that. So how to replicate basically means that you need to ensure that exact same pre-processing that happens during development happens during the basically deployment. And if you think about it, like theoretically, let's assume you build a distribution like this during your training, like development, and your model expect a distribution like that. Now, if during the deployment, this distribution is slightly shifted, right? This will impact the model because at the end, it's just some numerical operation, right? So you want to be sure that this basically works fine. Now, there are recently some of these libraries like TensorFlow, PyTorch, they have some capabilities that so when you build a neural network, especially if those of you are building neural network, it's graph-based, right? Every basically layer that you add technically is a graph node. So what you can do, so previously the way that it existed was this data pipeline that you have for TensorFlow, PyTorch, and then you have this model, and then this is the output, right? And this data pipeline normally is either in the same language, PyTorch or TensorFlow. Now, what you can do, instead of having this to be a separate, you could combine this together. So your data and model becomes one unified graph, instead of one graph for the data, one graph for the model. What's the benefit of that? The benefit of that is that, so when you train a model, you can exactly reuse those models that you trained, right? Why? Because it's a graph model, you can convert it to a frozen graph, save it as an object piece, and load it. Doesn't matter in whichever language you use. So if you develop something in TensorFlow or PyTorch in Python, they have an equivalent C++, like a binary loader, which doesn't care about the model. What it does, it's a package that is able to load the frozen graph and does the computation for you. So if you combine these two, your data pre-processing will be a frozen object that you can also basically load it and pass the data to. So you don't need to do any basically like a manual code writing for the data pre-processing in C++ or equivalent language. Of course, it has like some pros and cons. Can anyone guess what could be the cons, the biggest cons that you can see?
You need to change the pre-processing layer or something.
So that's correct, but even if they were separate from each other, if you change pre-processing, you technically need to, like if you change something about the data distribution, you needed to change the that component of the model also. So that's correct, but it won't be a cons of this stuff. Model size become bigger. That's correct. That's one. What else?
Pre-process every time before retrain.
You need to pre-process every time before. Yes, so but what will be the challenge with that? That won't be very consistent. So if you want to retrain, you need a preprocessor to convert the data in the correct format for the model. So anyway, you need this, right? So that won't be a challenge. I think the main challenge, so one is the size, the other one is the speed. Because previously you could have parallelized this, you could have nodes that are responsible for pre-processing and pass the node to wherever your model is loaded. But now this is one model. So the speed basically will be impacted, right? But the accuracy is technically, better than converting and writing this code separately, because it's kind of like becomes a frozen object. Now, when you try to write code, there are technically two phases, especially in machine learning. One is that the POC, proof of concept, which is the phase of a project that you want to prove this project is worth spending money and time on. It will work. This is something that the idea that we have will work. So as part of POC, your goal is to decide this will work. So you don't need to write a perfect code. Okay, so if you try to do POC, don't focus on writing a production level code, because that just delays the process. You want to write something that does the intention and it can prove the concept. But take as much as possible notes and add comments, so later you remember why I did this, so you can basically convert it. If you had a successful POC, then you focus basically and you shift it. Let's say you want to move forward with this application, you go to production. That's where you basically need to write production level code. That's where you basically need to be sure that the code is basically follows all the best practices. Now, there are some tools in the market that will be used for especially when it comes to data pipeline, like TensorFlow Transform, Apache Beam, Airflow. I think today we have a lab on Airflow. I think that's correct. But those are much better than just directly doing in Python. Python is actually by default is not a really good language for data pre-processing. Most of the companies focusing to put data pre-processing outside of the Python, right? Except for LLM that is shifting everything right now, because everything is written in Python. Yes.
But in Airflow also we are using Python for snippets, right?
Airflow we are using as a lab, but Airflow has support for other operators. It's not just Python. Yeah. So you can basically have the code written different. But in general, like we can, for example, use Apache Beam, which is much faster. I think we have some labs also on those ones in the next weeks. Now, on the other end, when it comes to LLM, there are some changes in the data pipeline that you need to keep in mind. First thing is that, well, you deal with lots of data. LLMs are really hungry for data, especially if you are training LLMs, right? It just typically goes in gigabytes and terabytes amount of data. Now, you need to be sure that you have a pipeline that can handle ingestion, cleaning, tokenization, batching, sharding, and streaming. Right? We're going to talk about those elements right now. You need to be sure that this pipeline basically is memory efficient and is scalable. And then you need to also be sure that all your GPU is fully utilized. Okay. Now, we're going to talk about all of those soon. So before we move forward, do you know, as part of the data pipeline, let's say you have a model, doesn't matter, LLM, deep learning model, or any model that's using a GPU, for example. Do you know how the data moves as part of your ETL? Anyone here? In extract, transform, load, basically, how the data moves between different components of your computer or your server. So,
Batches.
So like you have a data and you want to basically do an ETL, like extract this data, transform it, load it into your GPU. Do you know across your machine how this components will move from which hardware to which hardware and how. So let's just start here. So you have, let's say you have a data that's it's sitting on your machine, on your hard drive. It could be on a storage and in a cloud. So the first part of the ETL, which is the extract, right, is where you want to extract the data from where it's sourced. Right. So when you extract the data, this data, you can only extract certain amount, and that depends on how much RAM you have, right? So you have this like a RAM memory, okay? And you extract data from the hard drive, comes to the RAM. The next step is you want to do the pre-processing, right? So you want to basically do some processing on the data before it goes to the model. And normally the pre-processing basically happens on your CPU. Like we use the CPU cores normally for the pre-processing. Now, after the CPU, there's a GPU here, right? So let's say there's a GPU here. After the CPU, the data that's pre-processed, we load it somewhere else that's as close as possible to the GPU, and that's called cache memory, right? So you have something here which is called cache. Why into your cache? Because cache is the closest location to your GPU when you want to transfer the data, right? All of your laptops, basically, if you have a GPU on it, well, you have all this file. If you don't have a GPU, you have all this file. Whenever you look at your system footprint, you have a memory and you have a cache memory. And cache memory is normally much smaller than the RAM memory. What does that mean? That means if you load 20 gigabyte here, let's say you couldn't probably load 20 gigabyte here because you will run out of cache. Okay. So when you look at this, basically, the challenge that you have is that all of this, let's say this is our chip, even if it's a server. The expensive one is the GPU that you have down there. That's the one that you pay per hour and is normally expensive. So when you have a pipeline, the best thing you want to do is to utilize the GPU almost 100% of the time. That means you want this GPU to be constantly working. Okay. But what will happen if any of you build a proper pipeline, build the data pipeline on your laptop and profile it, what you will see is that most of the time the GPU is not doing anything. And these are the part that's working, and GPU is waiting for the data to come to the cache so it can pick up from. So your GPU is most of the time underutilized because it doesn't have a data as a batch. The batch data hasn't arrived here in order for the GPU to start the next batch. So what you want to do is that to put this somehow on top of each other, obviously utilize them. So this one is maximized. Let's get the utilization is maximized. Anything above 95%. Okay. We're going to talk about how basically you're building those pipelines. Yes.
So when we train any kind of model, right, we send the data into batches, right? So once one batch is finished, does it again go to the hard drive or again?
So the general data pipeline, TensorFlow, PyTorch, most of those, unless you specify how you do there's some concept we will talk later, it's called prefetching. If you don't do something like that, it's always sequential. When you start here, until this is done, you're not going to pick another one. It's kind of like a sequential. So you can see that this will always have delay. CPU is like waiting for this to finish, to GPU to finish. GPU wait for all this for it to finish. But your steps that you can take, like prefetching, which you instead of picking one batch, you pick multiple batch, as long as you can basically load it here. And then once CPU gets one batch, process it, passes it to cache, but as soon as it's done with the first batch, it already started the second batch. And so on. So you basically stack them on top of each other. So when this one, the GPU is done, it doesn't need to wait. There are also, sometimes there are scenarios that when your cache memory is small, you, after pre-processing on CPU, you can write it on the hard drive and load it from to your GPU instead of if you don't have the proper cache. Okay, it's not like all. So we will talk about more about how to build this, but this is basically in general when we talk about that some efficient data pipeline. These are the components that you need to keep in mind. Okay, now. So in general machine learning, basically, what you do, you use you have a database, you load it, and you use it for training and so on. When it comes to LLM, now you have this large amount of text that most of the time you cannot load it onto your machine at once, right? So you need to basically have some strategies for this. The challenges that you have is the tokenization you need to keep in mind, especially if you're using pre-trained models. They normally on Hugging Face, the model comes with the tokenizer also. So be sure that you're technically using the same thing, or you basically respect the tokenization that the model expects to see. Then efficient batching to minimize padding. That's the second thing, is that for text especially, lots of time your texts are not same length, right? So if you batch, don't do random batching. Why? Because you will have text that could look like this. And the problem with that is that you need to pad the small one to match the maximum size, right? So in basically efficient batching, instead of doing something like this, you group those based on the lengths that are similar to each other. So you will have one batch, maybe this is the longest one, but they're all similar to. And you have one batch, basically, it's kind of like a longer ones, right? So that way you avoid padding too much for text that they don't need to do that, okay? Sharding and distributed training is the next thing. Sharding, basically, the idea we will talk about further, but the idea is that how to distribute basically this data that you have across different workers, especially if you have multiple GPUs, how to shard those and for your training. And then the last one is like a streaming for large data or real-time data. And that's where you have lots of data. There's no way for you to load it. So instead of doing that, you stream it to your model basically during the training. So the model all the time receives a batch that is just fresh, basically was you read from the storage that you have. Now, for tokenization, I'm just skimming through this type of thing because I assume that you all, if you do LLMs, you know. But you just need to pick certain types of tokenization for your thing. So either byte per encoding, word piece, sentence piece, and so on. They're different. All these LLMs, they have, especially the new ones, they have different tokenizations. Be sure that you pre-tokenize the large data set. So if you have a data set that's large, maybe instead of tokenizing as part of your pipeline, you already store the data as tokenized data. That reduces the amount of time it will take for the pre-process. So store your data as tokenized and then continue from there. And then be sure that you handle, the sequence lengths that we talked about, end of like characters or vocabularies that they are not part of your vocabulary for your model or for your tokenizer or pre-tokenizer. Then when it comes to batching, which we were basically talking here. So be sure that you batch with respect to this length that you have done to naive batching. Be sure that you also, for batch size, be sure that you respect the GPU that you have. You need to do a test. First time, do a test to see how much data I can load in my GPUs before I get out of memory, right? Figure out that. Basically, that tells you that, okay, this GPU has the capability of this size data, and based on that, you can decide, okay, this is going to be my batch size, and this is my pad size, basically. Okay, so have that knowledge instead of keep trying and keep getting the error and going back, changing manually. First, try it, figure out what's the bandwidth for the GPU, and then based on that, do the batching. Then sharding is the next thing. So sharding is when you basically split the data across multiple GPUs or multiple workers. The goal of sharding is that across all the workers that you have, the entire data set was used. Okay, so if you have 10 basically workers and you have 1 gigabyte GPU, each one of them basically going to get 1/10 of that data. And total entire data will be usable. There are some of the, like, especially from the Hugging Face and partition and stuff like that. Yeah, this days is really easy to shard data. So you can basically do data set that shard, that's just an example, and you define the number of shard you want. You give it an index, you use that index by the workers to pick that data at the time of use. Okay, so these are like a much easier these days. When it comes to streaming also, it has becomes much easier for LLMs because the Hugging Face has really good libraries for those. So this load data set example as a parameter from Hugging Face as streaming, set it through. And instead of load the entire basically data at once, it stream the data and feed it to your model as basically the request time. So those are some things that you can use. And you can combine the streaming with the sharding also. So it's depending on what's your goal. Now, in general, putting it all together, again, this is just a bigger picture of this. So we will have class on this one's how to optimize the GPUs. Okay, so this is just a bigger picture for now. You need to be sure for your robust LLM pipeline, you do tokenization, sharding, streaming, and smart batching. Those are need to be there if you're trying to build your own model, because otherwise you're wasting the money that you pay here for the GPUs. Okay. Keep your goal is that keep the GPUs fully basically utilized, at least 95% of the time it's utilized. Avoid pre-processing bottlenecks, things like this, that you load something and you need to wait for the pre-processing. If it's pre-processing expensive, maybe pre-process ahead of time, store it and use that. And then be sure that you have proper version control. Okay. Now, these are a couple of tools that you can use for this, like Hugging Face datasets gives you those three options: transformers, PyTorch data loaders. Basically, there are other options that you can use, and these are like you can search and find online. But these are pretty unique for that. And the other couple of things to keep in mind for your pipeline steps: stream or load the dataset, tokenize, batch and pad, and encapsulate your scripts. So be sure that your scripts are also like modular. When it comes to industry level, you need to distribute the storage. That means that you're not reading from a hard drive, right? You're reading from some cloud services that the data is there. You can use data lakes, Apache Spark, Ray. We will have all of those. Streaming libraries, basically TensorFlow, TF data, PyTorch, Torch data. Those are all giving you that streaming options. Okay, in case you're using any of those. If you don't know how to monitor or profile hard drive, one example is TensorBoard. If you have worked with before or not, it's basically pretty unique for basically getting a profile over your GPU, CPUs, and stuff like that to find the bottlenecks. So that's just one example. When it comes to data quality, be sure to remove the bad data that you have, because normally you crawl the internet and you gather lots of data. So be sure that you first clean those ones. Avoid duplication. There are a couple of styles. You can use hashing techniques to see if these data are basically duplicate or not. And the one that duplicate or are similar, get rid of those. And then versioning and traceability. So you basically need to, for data, you need to do data versioning, especially when you work with this concept like LLMs also. So DVC is one of those tools, or data versioning, which is nothing. DVC is pretty, we will have a lab for that today, data version control. Okay, so, and then this is just modern tools. This is, I leave it here for you to read later, basically. Now, that's just an overall. Again, we will go over the data pipeline, but the most important thing right now is the concept of metadata, data provenance, and data lineage. Okay. Before we start, there are three terms here. I want to see three hands. You can tell me, what do you think is metadata when it comes to data definitions?
The extra data which is not, which is not supposed to be seen by the viewers, but it is needed for some extra processing stuff on the, behind the curtains.
Okay, that's good. How about data provenance? Data lineage.
Lineage, history of the data. show the track where it came from.
Yeah, so lineage is history. Whatever happens to a data on your pipeline, in your network, on your like company basically platform, that's a lineage of the data, right? Normally, basically, lineage is pretty important because companies need to know where is the data. So if someone send you an email and says that, okay, you need to remove my data, depending on also the state that you are. If you don't have a proper lineage, you cannot remove that person identity or data across your entire network, right? Think about this, like you have 5, 6 people in your team, you're building a product, 5, 6 different machines. Everyone has a piece of data. They go work on it. And most of the time you create a snapshot of this data, you create a second version of this data and so on. If a user, now you need to eliminate one user, it's hard to trace everything back. Right, so data lineage gives you that visibility that, okay, where did this data go, what transformation happened on it, and where it is now. So that way you can basically remove. Provenance, on the other end, basically is where the data comes from. Whose data is this? That's the provenance. The data provenance and lineage are two important terms when it comes to data pipeline. Where this data comes from, whose data it is. Okay. Metadata tells you where you collected, like when did you collect it, like what, maybe under what like agreement did you collect it, and so on. Those could be all your metadata. But the lineage is that from this moment where this data went, where it is now, what happened to it, could be all basically traced back. Okay, so that's the idea. Now, let's look at one data pipeline for the same example that we saw when you try to do user ID merging between an app and website. So start on the left corner. You see it spam data set. That's a data set that you have, which it has users with resumes and stuff like that, and you don't know which one is good, which one is bad. Right? So first thing you need to do, you need to build some ML code as a model to de-spam. You know, you basically could be ML code, could be just hierarchical code, software code, but you need to build something that's anti-spam. Because what it does, it goes over this data, cleans it, gets rid of whatever user we don't need, and pass it forward. Now you have a de-spam version of that data. Then you have another data set which comes about either the website or from the app. Now you need to have another model that basically can merge these two together. Right, so you have this clean user data. On top of clean user data, you build a model that does the job search and make a prediction, basically. Right? So when you talk about data pipeline is not just where you did the data cleaning. It's the entire history of what is happening on this data. Because if you just focus on one part, what about the next part? Right? So you have multi-components model, right? It's kind of like if you just focus on one and you miss the other ones, the impact that it has is kind of like the domino effect it has. It will impact the final output. So when you talk about data pipeline, don't just look at one component, it's the entire pipeline that you have. Now, let's look at another example. So when we talk about the, it's like a visual inspection that we saw, the cell phones that we were seeing for scratches or not. If you think about the metadata that you as an engineer could request to collect, could be like a time, factory line, camera setting, phone model, inspector ID, so on. But when it comes to like a speech recognition, it could be device type, labor ID, VAD model ID, or version, and so on. All of those are metadata. They don't go to your model, but you will use it later when there is an issue with a pipeline or with a model output to figure out, okay, is this a model related or is this something outside of the model? If you don't know, let's think about the manufacturing pipeline. You get a request from this manufacturing that the model that you have is not working. We had so many malfunction, basically, or defective basically phone past. And if you don't have a data like that, you either need to accept what they say and try to fix model, or send some engineers to the factory, spend the time and money, basically try to go over there and try to figure out what's going on. But if you already have collected information about the pipeline, lighting, and everything, you can just simply look at that and say that, okay, you know what? this one pipeline has deviated from what we expected to be the like a good environment for the model to work, right? So that's the important also of metadata. It also gives some information for debug. Now, so the next thing which all of you I'm sure familiar with, like is like when it comes to data splitting. Well, for your project, depending on what you do, maybe it's not the case for you if you do LLM, but you want to be sure that you have some random split on your data, okay? And the idea of random split is that to be sure those data that you have, your train, dev, and test, they are actually disjoint, okay? So if you work in healthcare, just one idea I give you is that if you try to split the data, don't split the data based on records, split the data based on patients. A patient doesn't matter how many records they have. If it's part of the training, that patient should not exist in your testing. Should be a different, totally new patient, because otherwise the model has seen the record for that patient, right? So be sure that you figure out a proper disjointing with basically cut, for basically breaking down your data. When you work with LLMs also, probably you have heard these days, they say that all the tests that we do on LLMs to see if they are good, they're kind of like biased because they have seen the entire data during the training. So when you test them, like they actually have that test data is contaminated. It has been seen by the model, So that's also a reality we have. Now, okay, so before we stop, now that we have enough of your teams here, before we go to the next thing, so we want to talk about your scoping. I look at some of the scoping documents. We're going to extend it for a couple of days, and these are the part that I'm saying that is general. Maybe it applies to you, maybe it doesn't apply. Some of the scopings are engineering focused. There is no business orientation basically in the scope. You don't have a goal that what am I building for who am I building? It's like just kind of like an engineering focused task. Even if it's engineering focused, you need to have an idea, okay, I'm building a product for this engineering group. I want to sell it to these people. This is how they are gonna use it, okay? So without that, again, this is just an engineering task, and that's not the goal. So if you're one of those groups that you actually haven't defined a proper, like a business plan, who are we targeting for, why do you want to sell it, and why do we think they need it? You need to go update that one. The other thing is that lots of you asking me for opinion on your project, right? I can't tell you if your project is cool or bad. All projects sounds cool. They're like ideas. So don't ask for me, because if I tell to everybody, it will be just whatever I want you guys to build, right? So you need to come up with what you think it's cool, like for you want to work on it, and just build that. It's not about me. I'm not going to grade your whatever product you're building because I like it as a cool or not. It could be something that I don't like it, but it's so great. I'm like, wow, this guy's killed. So build whatever you think you want. I will give you feedback like, is challenging, or do you have a data for it? Ask you questions like that. But I don't tell you that do it or not. It's your call, basically, if you want to do it. The other thing is that you need to be sure if you pick a product that you want to build, first think that, do you have data for it? Do you have an idea where you can get data for it? If you don't know that can you get a data even for it, and you have an idea, then you're probably going to spend weeks trying to find a good data and come back and say that, okay, we didn't find some data, we're going to build synthetic data, right? Other teams, they have done that. Synthetic data is fine, but the problem is that you automatically build it toward what you want to solve. Like it's a clean data for the problem that you have that you want to solve. It's not a real data, right? So think about the data. We're going to extend it for like probably through the end of this week. If you don't have a data, or you have a small amount of data, first figure out, could we find this data? Is like something that actually feasible, not just, it's just a cool idea. Because if you actually don't have data, You don't know where you can get this data. Building data is not easy. That's why companies are selling data. Okay, if it was that easy, everyone just build their own data, then those companies didn't have any business model, right? So work on that. Be sure that you have a data. Okay. The third thing is that some of the projects or products basically, they sound really cool, but they sound really challenging at the same time. Okay. I want to be sure that again, from my end, it's like, wow, this is cool. If they can, these guys can pull this off, is great. But I want you to also be honest with yourself. Do we have the team to build something like that? If you believe you have, then great, build it. If you don't think you have, I don't say not to build that. Maybe reduce the goal that you have. Maybe for now, just build a section of that product that you have in mind, not that bigger picture. You define your MVP to be something that's smaller, something that's more deliverable and manageable. And then later you learn, as you work on it, you learn. And then over time, you can basically, for the maybe I don't know, next semester, like you decided to make it your company and say, okay, now we're going to do this part, right? So just be sure that that part also you have thought of it, okay? Again, it sounds cool idea versus feasible. They are really two different things, okay? I think the last thing is that for compute, okay, you need to also account for how much money is going to go inside some of these projects, okay? If you just try to do LLMs, account for the cost. It's not going to be cheap. And if you everything that you do is going to be API calls and stuff like that, at first, don't do that. At first, pick one of these existing Gamma, Llama model that you can run it on your local machine. Work with that, even if the answer is not perfect. Be sure the entire pipeline can work with this one component. Later, during your pipeline or during your deployment and everything, you swap that model with a good API call. So don't try from get-go to make API call constantly because you just increase your cost. And then you get to the point that's like, okay, it's for this class, I spent too much money. You don't want to do that, right? Technically, that whatever budget that you have, 300, 250 from Google, that should be enough for this, whatever you are building. Okay, so pick one of Gamma's Llama model, or I think GPT OS, something like that, that also runs on your local machine, and then test it. The result doesn't need to be perfect, as long as it does similar tasks for you, and then later swap that. Okay, so we're going to extend the deadline for a couple of days. If you have something like that in mind, just to be sure to update it. Sorry, one group asked a question about existing graph or flow chart about the product. What I meant by that is, if you're building something that already exists, like someone else has a product and you're like, I want to build something, I want to make this better. What you want to do is create a simple chart. This is like something like this, that shows in the current market for that product, what is happening in the product. And you can say that I'm going to improve this part. My product is the same thing, but improve this part. That's my business plan. I'm going to make it faster or make it better at this location or cheaper. Okay. So be sure that you have, if you're building something new, so you don't need to have this because you might not know it yet. But if you try to mimic someone else's product and just make it better, then you need to have an understanding of how does that thing works. And when you say I want to make it better or want to improve it, what do you mean? Which part do you want to improve? You're not going to improve all of it, basically. You just pick a component of it. Is that clear for everyone? Yeah? All right. So, come back to this. Well, yeah. Okay. All right. So the next thing we're going to talk about is like in general about data, but it's going to be collecting, labeling, and validating data. First, let's start by two phrases, like an interesting one. And these are like from large companies. Like one is Uber, the other one is Gojek. Gojek is kind of like in East Asia company. That's similar. But basically, from Uber's perspective, is that data is basically the hardest part of the ML, and is basically the part that is worth spending more and more time to make it right. Okay, it has the highest basically ROI. That's the same thing basically for Gojek. Basically, it's like basically they say no activity in machine learning lifecycle has the highest ROI than spending the time on the data. Right? So all of these companies, they have figured out that the better you have this data on your data processing and data pipeline, the better the outcome. So they don't spend time on the model as the best part of the pipeline. When we talk about ML, basically ops, or basically ML lifecycle, it's technically the model development plus the software development. But there are some challenges in these types of model. One is that if you think about the data iteration loop, you have data, you do a training, you do evaluation, and you loop through them. The result is some model, right? So that's basically what you work on. However, as we talked about before, the amount of time that technically goes to that model development is going to be the smallest portion of the entire project. You know, you're going to spend the rest of the time on data deployment and packaging. When remember in the previous class we talked about data-centric view and versus model-centric view. Data-centric view was which one?
That we spend more time on data and not on model.
Right, and model-centric view is what we spend more time on best model, academy versus industry, right? So here, if you think about it, in academy and research, data is static. The priority for design is going to be getting the model that has the highest accuracy. Model training, your focus is at optimal tuning and training. That's the focus that you have. Model fairness is really important these days in publications, in academy. And the challenge that you have is how to build a best model, how to build the highest accuracy model. But when it comes to production, like in industry, data is dynamically in this case shifting constantly. The priority for design is not the highest overall accuracy. It's in general, it's like a package should be like a fast model. You want fast inference, right? Because you could have the best model, highest accuracy, but user spends like 20 seconds for getting an answer, 10 seconds. And they're like, after a couple of questions, like, I'm not going to use that, right? So you want something that's fast, at the same time has a good accuracy, but you don't want the optimal accuracy like the way that in academy anymore. For model training, instead of optimal tuning and training, you focus on continuously assess and train. You know, that you want that pipeline to be able to detect, retrain itself. Fairness is crucial in academy, is really important, but it is crucial because you can get sued, right? And the challenge is that the entire system versus just having a high accuracy model, the entire pipeline that you have is the challenge. So when you talk about ML ops or ML basically in production, machine learning development plus modern software development. That's the focus that you're going to have. When we talk about data, its life cycle of data, it starts with the label. So you first need a label, right? Then you need feature space coverage. What does feature space coverage mean? If you say my data has a good feature space coverage. Yes.
It covers all the aspects of the real world.
Yeah, or even not, if not all the aspects of a real work, all the aspects of the space that you want to target. That means if you're selling data, let's say you're targeting age group between 18 to 40. That's the target that you have, and you have this age characteristic, like a feature. That feature needs to cover from 8 to 40. If all of a sudden there are some age groups that you don't have those, then the coverage is not complete. You're missing that core or that group. The next one is minimal dimensionality. In general, by default, you want to always have the minimum dimension, right? As much as possible, because the higher the dimension, the higher the cost, right? And also becomes more challenging for coming up with an optimal model. We have the large space that you want to search through. We're going to talk about this, but think about this. You have a 2D. This is the search space that you have. As soon as you add the third dimension, this becomes the search space. Now, if you keep adding dimension, the search space becomes really large. That becomes really hard for your model to find optimal points. And also points by default in a larger space are farther apart from each other. That means if a point here exists here and the other one here, in 2D, they are close to each other. In 3D, one might be here, one might be here. As the dimension increases, the distance between similar points actually becomes farther from each other. And if you work with the types of model that are distance-based, that becomes really difficult for detecting if these two are similar or not. The next one is maximum predictive data. So you want to be sure that your data has the maximum predictive signal, right? What do we do in order to increase that predictive signal? In feature engineering? Yeah.
Combine features.
Fairness, and then the data basically is fair. Also, it covers the rare conditions. If you deal with the data that has rare condition, it's kind of you could misunderstand it. Sometimes people call it anomalies. You see a data that only repeats maybe once or twice, and you're like, this is anomalies, I'm just going to get rid of it. But sometimes those data are rare conditions, something that you will see, but rare, not often. In medical, that happens a lot. This is certain disease that they are really rare, but it happens. You can't just remove it because this is just looks like an anomaly, right? You don't have the domain knowledge to get rid of something. So if you see a rare condition data point, don't just remove it. First, if you're trying to remove, have a reason for it, not just removing it because statistically they are dissimilar. No, it should also be from the domain perspective. Now, well, you can basically account for it. So in healthcare, for example, you cannot upsample because where you cannot build humans, but maybe you can give them a higher rate for detection. Right, so you can basically give them higher rate because they are rare, or you can try to have some sort of hierarchical model. So first you detect this, then for that group you have another smaller model that focuses on detecting those versus the other, and then like you try to break down the problem.
If not healthcare, can we have synthetic data for rare conditions?
It depends on the domain. So if you work with, I'm not a good person to answer like about the I don't know, like e-commerce, but I assume in e-commerce you can build data like that. Like I don't think you can, for example, in anomaly, you can't just build anomaly unless you have a domain knowledge that if anything above this number happens is anomaly for this characteristics, right? But I think it depends on the domain knowledge that you have. So when we talk about modern software development, first thing is that it should be scalable, right? So your model should be scalable, basically. It should be extensible. Extensible means that you can add additional things to it. It should have a proper configuration, consistency, and reproducibility. That means you should be able to reproduce the results that you get. And these are accounts for whatever you're building end of the term, right? So your code basically should follow these rules. It should account for safeties and securities. It should account for modularity. That means you all know that don't write a long code, right? You have to break it down to do a specific task. It should be all testable. You have proper testing for it. It should be monitorable, and in general follows best software practices. So I'm sure you all have done enough coding that you know that, but just try to follow certain things. Now, when it comes to ML, on the other way, you need to be sure that whatever you build is an integrated ML system. Okay, if you have a pipeline that does components like these components that they do tasks for you, build it somehow that you could pick a component from your pipeline and replace it with something else without breaking the pipeline. Okay, so try to be sure that these components that you have are somehow that you can configure or change pieces. Instead of, if I need to change this, I need to change the entire code. You know, I'm not talking about the model training. Maybe if you change something in the pre-processing, you need to do retraining on your model, but about how the components interact with each other and how the data will be passed from one component to the other one. Be sure that you can continuously operate the in production. You can handle the continuous changing data. We will see more of that, but as we said before, data will have a schema. One of the ways that for your pipeline to ensure that it receives valid data and passes valid data to the model is to do a schema verification. When you have a data during training, you build a schema over it, and the schema basically says that, well, I expect this column to be integer, right? I expect this column to be categorical, and these are the number of categories that exist in this. That's the schema. So when the data comes through, you always verify. If this all of a sudden you are constantly getting a float when you expect integer, and the categorical one, you are keep seeing new category that was not part of your training data. You need to make a decision what I want to do here. You either reject this, consider that it's all like abnormal data for my for the expectations they have, or you improve this constantly, like continuously. That means you add the new category to your expected categories, and then change the schema dynamically, shift the new schema to account for this ones. Right? We will have a schema rules later, but you need to account for continuously changing data, because data that you see in the market is not going to be a fixed data. And then finally, optimize the compute resource that you have. Now, this is just supposed to be for you an ML pipeline. Okay, when you build this pipeline, data goes through, it comes out somewhere. Okay, now when we talk about ML pipeline, the definition is that an infrastructure for automating, monitoring, and maintaining model training and deployment. Okay, so infrastructure for automating, monitoring, and maintaining, right? Model training and deployment. Now, this entire pipeline that you see here, it's an ML pipeline. It starts from data, scoping data, modeling, and deployment. Now, what you see here is that there is a line between data and modeling. There's like a two-way. What does that mean? Well, if you change basically anything in the data changes, sorry, it's one way. Anything in the data changes, model will be impacted. So, you know, you need to basically go back. If your model, basically you develop a model, goes to deployment and it doesn't work, you need to go back to the model. If the modeling doesn't work, you go back to the data. This is kind of like a loop. On the other end, there's a line from deployment to a scoping. What does that mean? That means you built something, you deployed it, all of a sudden, it does not match what you were planning to build. It fails, like it doesn't work. At that case, you need to basically go back to a scoping and change the scope. You know, that's the worst case scenario for you happen, because you need to redo so many things. But that's also possible. You have idea, maybe it worked even in the POC, but then all of a sudden when you deploy it in a real world, and then it's not working. Okay, so this is going to be the loop that you go through. Now, this chart is one of the charts that you can find online, but this is by CD Foundation of basically for the MLOPs. Now, they define the MLOPs to basically, or ML pipeline, to look like something like this. Okay, and again, every company has defined their own, but they all have this 4 components same. Okay, so it's going to be the scoping, data modeling, deployment. It just what goes through this basically stages are going to be a little different. But here in City Foundation, they define by the data pipeline to be data cleansing, ingestion, analytic, validation, engineering, splitting, so on. Then it goes to the modeling, and you go through the steps, and then you go basically to rollout. On the right bar, yeah, you have data consistency, data versioning. That's where you version it using something maybe like a DBC. And this is the data flow and workflow orchestration. That's where you have a maybe streaming data pre-processing that which can be orchestrated and pass the data for the next pipeline. And on the left, you have this marketplace AI hub in case you're basically using some. But the idea here is that for you to just understand that all these companies, they are basically looking at the MLOps in the same way. Okay, 4 components, it just maybe they have different subcomponents. Okay. Now, how many of you have worked with DAGs before? Okay, so DAG, directed acyclic graph. Okay, it's basically a directed graph that is really useful, especially in ML or in a pipeline where there is it's acyclic, so there shouldn't be technically any loop, and you're trying to orchestrate some tasks. Now, in the idea of DAG is that, let's say you have data, like as part of your pipeline that you're going to build. You start with web crawl. That means you have some sort of code, agent, whatever you call it, that it's basically start searching internet, downloads the data. When this one is done, the data that it's collected goes to somewhere that's for cleaning. When cleaning is done, it goes to, I don't know, tokenization and so on and so on. So, or maybe here there's another subtask, I don't know, like for one time you do cleaning and the other time you create, I don't know, maybe not exactly, but a schema. When you have a pipeline that looks like this, it's like a sequential, you can build a DAG. Okay, DAG is becomes something like this. Every node is feeding the data forward or after. You normally do not have cycle. It's possible some companies they do cycle, but by default, DAGs they don't have cycle. It's like they're acyclic graphs. Now, most of the platforms that we use in the class for data pipelines are going to be DAG based. So it becomes that means you build the first, you come up with an idea of your data pipeline maybe, or your model training pipeline, like the steps that you want to go through. Based on that, you build a graph. And every node of that graph becomes a modular component that you want to do a task with. Okay, so that's much easier for managing. So that is definition of that clear? Yeah. Okay. So there are some of the pipelines that you can use for DAGs, like Airflow, Argo, Celery, BG, Kubeflow, and so on. There are like all sort of platforms out there that you can utilize. We will have labs on Airflow and Kubeflow. So Airflow is the one we did today. Kubeflow is like useful for if you work with Kubernetes, basically. You want to build your own DAG version. Now, we also do TensorFlow Extended, TFX. So TFX is a library by TensorFlow by Google. TFX stands for TensorFlow Extended. It's basically end-to-end ML pipeline if you use TensorFlow, right? So if you're a TensorFlow user, this pipeline gives you, this platform basically has from data ingestion, validation, all the way to model serving. It's basically in one library package and it's free. That's the benefit of the TFS. Maybe have one example of this before we go back in. So what they have done in TFX is, how many of you here have worked with TensorFlow actually? Okay, so some of you. So TensorFlow has different libraries that you can use for different tasks, from data ingestion, data validation, and so on. So what TFX has done, it brought all those libraries, connect them together in a way that the output generated by one library is in a proper format for the other library to utilize. So instead of you going to do that, they already have built this unifier that the output from one library exactly expected by the next one and so on. We will talk about those outputs. But basically they have start with an example gen. And this is something that you, for your pipeline, doesn't matter which library you use, you're basically going to do something like that. Example gen, basically what it does here is just loads the data. It's kind of like basically it just loads the data from your hard drive and so on. Then you have, as part of data validation, you have a statistic gen, a schema gen, example validator. So a statistic gen or statistic generator, what it does for the training data, it gathers all the necessary statistic that training data has, store it somewhere. So you end up with this basically maybe graphs of like a node. Every node has mean of this column equal to the standard deviation and so on. So you have this statistics for your training data. Then you have a schema gen, which is what we were talking about. It builds a schema over your training data. Then when you see on the bottom example validator, what it does, for the test and validation data, it validates those against your training data, statistic, and a schema. And it tells you if there is a data in your validation or in your test data that does not meet the expectation that you have. Right? So then over there you have choices, either get rid of something or you want to update your schema or statistics or whatever you want to. Then you have something called TensorFlow transfer, or PyTorch also has PyTorch transfer, which is you can build a pipeline or basically components for the data transformation. Next thing, it gives you a tuner and trainer. So you went up to the transform at that point, and these are all goes back to what I said at the beginning of the class. You could have one component that could have your data from your data all the way to the model as a full graph. All right, so this basically, you can basically package this in that way. So transform basically has the data that is already transferred in the format that you want to use for model training. Then it gives you tuner and trainer. Tuner allows you to do the hyperparameter tuning. Trainer allows you to, over that hyperparameter tune, to train the best model that you can do. Evaluator basically is a component that allows you to validate the models that you have built, or across multiple models decide which one is the best that you want to use. And then you have infra validator and pusher. Infra validator is the next step. Now I have a model that is good, like a validator, so this one is good. Infra validator validates that if that model can run on the infrastructure that you're targeting to put that product on. You build something and then you want to see that, okay, I built this on, I don't know, H40 GPUs, but my customer, they only have A10. Can this run over there? So that infra validator validates that step for you. And pusher is kind of like okay, this is validated. It's kind of like a CI/CD. This is validated. Push this model to where the model registry is. And model registry is the location that we're going to register the model with the proper version. And model server is where, as part of the TFX, it loads the model, it creates an API for you that you can expose that API to your web site, or just an API basically address to your customer to make a prediction request. Okay, so TensorFlow has packaged all of this in one library called TFX. You can just install it. And there are sort of labs we have on this one for you to use. Now let's go back here. So these are some of the orchestration tools that you can use for ML versus LLM. But I'm just going to let you read the names. So it's like Kubeflow, MLflow, Metaflow, Zenflow, Airflow. So we will do the first two, Kubeflow, MLflow, and Airflow as labs, and you have labs on those. And then here, probably you have worked with series of these if you have done any of the LLMs, but it's all like from LangChain, LangGraph, Llama Index, Haystack. These are all like tools that you can use for your LLMs, right? So depending on you are doing ML or LLM as part of your product, you want to look at one of these tables to work. Okay, so there are again labs on all of this. Now, the last part that I want to talk about here is that on the pusher side. So this is the same thing that you saw here as just a hello world example. On the pusher side, when you build a model, let's say you build a TensorFlow model or you build a PyTorch model. PyTorch also has similar package. You want to send this model to different types of customers. That means one time you have a customer that if they are using through a hub or maybe through a website, or you have a customer that your cell phone, you want to have access to a model, or you have customers that their normal computer, they want to basically access through a computer, laptop. So depending on where you want to serve and how you want to serve it, you have options. So you have TensorFlow Hub. It's kind of like a hub that you can put the models over there and use it like what you use in Hugging Face, right? That's a hub. You can go download the existing model and work. You can do TensorFlow JS if you have I don't know, like a UI, a website, and you want to know JS basic version. You have TensorFlow Lite if you want to do anything that runs maybe on cell phone or on edge devices. You need to convert that to a light version. Okay, so it's kind of like what it does. It picks a large model and break it down into a smaller version, like by quantization or by basically pruning of the model, so it can run on a lighter version of the model. Right. So if you, how many of you have worked with BERT before? How many of you have heard the term BERT light? Right. So that light that you hear the term light after models, that's the idea here, that you can run it on light server basically. And TensorFlow serving is just when you use TensorFlow to expose an API and then pass that API to your customer. So they make a call to that API through another IP, so you don't expose the actual IP. You have a first IP and then you reroute the IP basically to your TensorFlow serving. Okay, so now the idea was that for your ML pipeline, you need to do automation, monitoring, maintenance, and end-to-end, right? So you want to, ahead of time, start thinking that I want a pipeline to account for my data, everything that happens on my data. It has everything that I want for my model training, model versioning, and it also accounts for model serving, so the pipeline is going to be the entire pipeline. Now, not necessarily like in reality, I personally even haven't worked with one component to do all. The reality of the libraries that you find in the market is that each one of them are good for one thing, right? So you just need to figure out what do you want to use for your data part, what do you want to use for your model part, what do you want to use for deployment part, what do you want to use for monitoring. They all have pros and cons, and there is no one fit all. It's not like that this is in the market. There's one library that can do all of this. So figure out which stack you want to use as part of your development based on the cost, based on the speed, or whatever is the primary goal that you have, and then basically utilize that. Now, let's go back to data again, because this is what more important. Collecting data, and this is like what we talked about at the beginning of the class, part of your scoping. Some of you asked me like, okay, I don't know exactly where I'm going to get the data and stuff like that. But importance of data collection is that you want to be sure that the data that you collect, first, even if you can't find it, you have a right to use it. Okay, so if you find a data and you want to use it, and you have some goals that you want to actually build a product, do you have the right to this data? Can I download it? I can download it, but can I use it for the task that I want? So you need to read those data cards that exist. Most of the time these days, data sets, they have a data card. Data card, and there's also a license, which talks about if you can use it under like a certain basically conditions. I don't know, any one of you here has requested medical data and put my name on it? Okay, that's why I received some emails. I need to approve this. But so these examples are for these groups that they are trying to build something with medical, and there are some data out there through PhysioNets and stuff like a Mimic that are realistic healthcare data. But those companies, they have rules in order for you and your team to be able to touch that data. First is you need to sign up a petition, and I'm going to sign it and say that, okay, these are doing part of the class. But then second, you need to get something called CT certificate, right? CT certificate is a certificate that you need to go through this course. It's quick, but it says that I have learned that how can I access, manage, and maintain health record data. Without that, these teams are not allowed to have that data. And everyone on the team need to get that license in order, if let's say down the road, they want to build something and they want to publish something where something comes out of it, they need to all have a license, because later they can be sued. Okay, hey, you know what? You signed the contract or you submit this, but someone else was added to your team and you don't have license to utilize that. So it's really important when you get where you get to the data, read the licenses to understand that, okay, could we use it? Can I use it? And so on. Also, it's just an example. So let's say you want to build the data on a model for security, and so you all went through airports, right? And those devices basically they have some AI behind those. That's also the a screen that comes and can detect things. Now the question is that if you want to build something like that, well, I need to get a data, but the first thing is that you need to get license to collect that data. So when I was a student, we had this project that we needed to go to hospital in BWH, and it was part of the operation research project. And we wanted to optimize as operation research and supply chain. We wanted to optimize bedding and doctor assignment for patients. So the idea was that how to ensure that the doctors will be only assigned to the rooms that are as close as possible to them, so they don't need to walk back and forth. So we got licensed, and like a lots of training we went through to get a badge that so we can be on the floor and stand by a corner as a student. We literally were sitting there in the standing corner. Whoever was passing, we were marking it with the time, which it's annoying by itself. Back then, I was like, you just need to wait over there and collect data. But even that process of getting actual data, we went through a lots of process to get the permission to be on the floor to collect the data. So collecting data in real life is not going to be easy. Lots of time you need license, you need to get permission and so on. And lots of time they don't give you the data. So startups, one of the challenges you might have, not LLMs these days, which is crowdsourcing the internet. If you try to build something that's kind of like has a sensitive data, you can't find online, you can't buy it, no one has the real data to sell you. So as startups, especially if you work with healthcare, lots of startups, they go find hospitals that they are research hospitals, and they allow them to utilize some data. But then you need to go through so many processes. First, prove that you can de-identify the data. That means you need to first prove that if you give me your patient records, I will remove any identification for individual patients, which itself, if you can do that, you can build a startup on it. Right? Because the identification is really challenging. If you ask, I think LLMs also do, so humans, they have a 91% accuracy rate for 92, something like that for the identification. I think LLM is like about 95, 96. That's kind of like that. So it's not that easy. But the hospital, they ask you to prove that you can do 100%. So company maybe spends lots of money manually to identify in order to get a data, small data that you can actually build upon. So data is really important. But the other thing is that the quality of the data is also important. It's not just the getting the data, it's just the quality of that data. Now, in machine learning, we say data is the first-class citizen. In software programming, code is the first-class citizen. Machine learning, that has changed. So this new, I think this terminology came in an interview by Andrew Karpathy like years ago, could say about software 1.0 versus software 2.0. So ML basically called software 2.0. The idea is that because in ML, the focus is on the data, not just the software. In software one letter, the focus is on the code. Here, the focus is on the data. On top of that, you need a good code because if you don't have a good data, that's what happens. I wait for you guys to read that comic. See what's your reaction. That's what happens. If you don't have good data, a pile of data, all you can do is keep string the model that you have. Hopefully, one of them gives you a good result. Right? Now, you want to be sure that you have, focus on the understanding. Models are not magic. You can't have a model that does everything, especially if your data is not. Meaningful data is a data that has a maximum predictive contents. You got rid of all the noises that it has. You focus on the part that's important. You have removed the non-informatic data, and it has a good feature space covered. Because all of that gives you one thing, right? Garbage in, garbage out. And this happens a lot because you have data, companies has lots of data, and you don't have the engineer actually to clean it, right? You either need to outsource it for cleaning, or you're like, let's build on it and let's see what's happened. And you build, and over time, you're like, why this model doesn't work? And I have done this from experience, to be honest. Why this model doesn't work? We go manually, pick some example to see why it doesn't work. But then we are like, what's supposed to work? We went back to data that we had during training, which was lots of data. We brought this data that we tested. We searched through the data set that you have, find like some sort of like a cluster of the similar data to this one. And we look at the labels that we have, and it was all over the place. So we were expecting to see one label, but when you look at the cluster of this data similar, they were like a 30% of this class, 30% of this class, or 40% of the other class, because the data was pretty bad. But because you have a large amount of data, especially when you're in millions, who's gonna really do that, right? So it's really important to understand that good quality data, it will impact the model, doesn't matter how good is the model. So we are going to talk about data collection, ingestion, formatting, feature engineering, and feature extractions. But it's not the only thing. When you hear the data, it's not only that part. During the deployment, you also have data. Right? So data that comes from your error, your model prediction, like latencies and all of this, serving failure. Those are the data that you need to give same importance to. Because this data is good for building a model. This data is good for maintaining the model. So you need to give same importance to the data that you get from deployment, because it easily tells you if something is wrong, if you have a shift or drift in your data, if you have a pipeline that doesn't work, if you have a hardware that's not good enough, or so on. That knowledge comes from here. Okay, so now let's do one example. So let's say this is the idea. You want to build an app. And this app is supposed to, as a runner, if you're a runner, you're basically going to use this app, and this app is supposed to suggest you which path to run, but not randomly, based on other users that are in the same level as you as a runner. So the app has other runners that are using it, and you're like, I'm tired of my normal path, suggest me a path. So you're basically supposed to find other runners similar on the same level as you, and look at their paths and suggest you a good basically running path. So what is what's the user that we have? Who's the user? It's a runner, right? So you know that I'm building this for runners. But then the question is that, what is the user need? Why should the user use this app? Because I know users the runners, they want to run more often, right? But basically better. So that's the user need for you. That's the definition. Then you need to define a user action. Have you heard the term user journey? The user journey basically is from the moment user comes on your app or platform through the end of the time that they use them. The journey that they go through, everything that happens. It's kind of like a lineage also. So as part of user journey, the next thing is that, okay, what's the user action? What should user do on my app? Okay, they are going to click on this, maybe they hit and then they get offered the run or pass, and then you're going to complete it. Now, you need to basically also remember something. Well, what if the user didn't complete the run? I personally, when I go to the gym, I use there's an app. I always start the program. I always forget to end it. The day after that I go, it's already passed. It's okay. It tells me, do you want to complete it? I sometimes say, yeah, sometimes I close it and so on. So from the perspective of app, you could say that, well, user didn't do it, give a negative feedback to the app, to the algorithm for suggestion, or say that I can see the user was on this program for this many hours, scroll through, collect some metadata, kind of like an indirect feedback to decide if user actually did the run. If user actually used the program to do. So so it doesn't necessarily need to come directly from the user to say I finished it, because sometimes you forget. Sometimes even when I run, I forget to turn off the Apple Watch, and then I just basically leave it, and the day after is still on like 20 hours of doing something. Right? So you need to basically account for those types of things. Now, ML system output, like this is the part for you that we want to decide. What is going to be the output of my model? It's going to be which route to suggest, basically, and when to suggest this. All right, so let's say this is the idea that you have. I'm going to suggest user to run, but also from their previous history, I know when they ran before, when they were completing it, when did they enjoyed it, and so on. I'm going to suggest that also the time. Maybe user is like during the day, like a 2, and you have a feeling that your user is tired or fatigued, and it's like, hey, maybe take a run. This pass looks really good. It's kind of like a time and the pass. That's what your model will be. And then what is your model is going to learn from the interaction that you have with the user. First, patterns of behavior around accepting the run. You can easily understand if the users, maybe there's a user like me, doesn't complete it, but that means they did it. So you learn the pattern from a user. Maybe a user always completed. So if they didn't complete, you can assume that they did not finish it. You basically do that some sort of like a user profile. Completing runs, if they did, for example, you feedback to your app because there was a good run, maybe they enjoyed it. And improving consistency, like basically that's the what your model basically learned. How many of you have heard of user profiling before? Like, have you heard of companies that the apps that do user profiling? Like, how often you get the ad? You're like, how did I get this ad? I was just doing something. Right? Imagine you just you give a GPS location to one of these apps, allow on your phone to have your GPS location, and then you're standing in front of a store, and tomorrow you get the ad for that store. You based on the GPS, they know where you are, how much you spent there, and then what's the store there. You get the ad for that. That's the idea of user profiling. User gives you the permission. You build the profile around you. They just basically follow you. They track you all the time. The good thing about Apple is that it tells you sometimes, do you want this app follows you? It gives you sometimes this notification. Mine is always like, close. I don't have Siri. I never had what do you call it? Like a FaceTime or not FaceTime, the face recognition. I was like, I was passive. So don't just say it. Don't want to do any of this. But anyway. So now you get some example from some users. You have these labels and they are fun. They label the data for you. So user finishes the run, but they also give you a label, like you put a thumbs up or 3 smiley faces. Smiley face like a unhappy person, or it's like or you can just put low, high, medium, whatever you come up with. And user selects that, they give you that feedback. If you can get feedback from user, that's the best case scenario. But we will see most of the time that doesn't happen. Now, the next thing is that get to know your data. Okay. First, get to know your data. This is for you as part of your next step, post your scoping. Where are you going to get this data? Get to know the data doesn't mean that, well, it is the data, I'm going to do EDA on it. No, EDA is not about get to know your data. It's understand the source of this data, where it comes from, who put it online. Like it's like a phishing data is just like a data, you know, probably we talk about data poisoning, like people poison data like hackers and they just leave it online and then you go download it and that data has some intention with the intention that you will use that in your training and later something comes up like a phishing email or something like that, like a bad link or you know stuff like that. So that's called data poisoning. So understand the source of this data. Check if they are refreshed. You might find the data for a task, but it's like from 20 years ago. Never refreshed, never any updates on it. You don't know the owner, probably don't use it. Right? It's kind of like a random data. So be sure that wherever you find this data, like if you go on UCI, they have a refresh. They have data card says that the last time the company updated this data a year ago, 2 years ago. Or some people, there are some GitHubs that they have data, but you see, if you go to issues, they have interaction with people on the market. People request something or they answer. If we just someone put the data online, probably they are not the owner of the data. They don't have a right to it. They just put it there and you're just picking with them. Be sure that you check that data for consistency, data types, you check for outliers and errors. All of that could happen by finding a data card, which again, most of the good data sets these days, they have a data card. If you find on Hugging Face or UCI data repository, they all have a data card. Data card and license. You can just review those. Then check for data set issues. You want to be sure that simple issues like zeros, integer versus float zero, it basically they don't exist. Account for compounding errors. So compounding error means that if you have if you think about that pipeline of the resume and job, you have multiple models that they feed to each other. So, guys, what's going on? You have multiple models that they feed to each other. So, if one of these models at earlier stage makes a mistake, the data that it generates has a compounding effect on the next one, right? So you need to also account for that. Well, this compounding effect will impact the model performance. Monitor for data source and system issues and outage. Those are like part of the monitoring that we talked about. So it's not just a data processing pipeline, is the deployment pipeline also, data that's being generated over there. Then the next thing, the measure data effectiveness. Intuition about data can be misleading. Sometimes you download the data and you have access to the data and you have this intuition that this data means this, or this data has I'm going to answer this problem. Lots of time we make mistakes. We have some intuition, but it's not actually valid. So in your team, especially, try to if you're making an assumption, don't bias your teammates. Ask them maybe in a different way the question. See if they can see what you are saying. Because don't make assumption. Feature engineering can help maximize the predictive signals, but feature selection helps measure the predictives. So feature engineering maximizes, feature selection, you basically to measure because that's where you're like, okay, I don't want this feature, I'm going to drop this or keep the other one. Now, this part moving forward is going to be a document that you need to submit as your next submission as part of the data. You're going to get a worksheet that you need to answer certain questions, part of your worksheet, that these are the components that I thought about and this data, and it's going to help how I'm going to use it for my product. First thing is that you need to translate the user need into data needs. If you are building an app for runners, user need is they want to run more often. That was your assumption as a user, right? Your product probably has a different user. So that means the data that you have could basically account for this user need. You couldn't just have I have an idea that I want to suggest user to run better, but the data doesn't have that information. All right, so you need to be sure that you can translate user need into the data needs. Data need that you will have probably is going to be running data from some app. You need demographic data, and you need to have a local geographic data because you were supposed to offer a good pass for running. So this could be three data needs that you have. Then you need to understand also what features do I need. You need runner demographic, time of the day, completion rate, pace, distance they ran, and so on and so on. If you can collect certain information, if you're building an app, it's not easy to collect, depending on if you're iOS or Android. So you need to be, we get different permissions, but if you have access to geographic data from user, just be sure that that needs to be protected. It's a sensitive data. Then you need to have labels, and the labels becomes runner acceptance or rejection of the recommendation that your app is giving. Basically, if the user gives any feedback, like some users they provide feedback, some users write, some users give thumbs up, thumbs down, and then some users may even give you a rating and say that they like, that you enjoyed the app or not. So collect those information and sometimes try to basically indirectly create some additional labels that are not directly come from the user. Because again, some users like me, they don't give feedback. Now, your finally, basically what you want to do is understand the user, translate their need into data problem. That means what kind of and how much data is available. What are the details and issues on your data? The data is not going to be clean and perfect. Doesn't matter where you get it, you're going to have data issues. What are your predictive features? What are the labels you are tracking? And what are your metrics? These are around your data, and you want to basically understand this. Now, I'm going to continue, then we'll stop, take a break, and we have labs. When it comes for your LLM, depending on what's your project, if you are doing fine-tuning, maybe it's easier. If you're trying to build something yourself, you need to basically first figure out that data. There are some data, again, perfectly available on Hugging Face and stuff like that. So figure out which data you want to use. Is it domain-specific data, or just prompting, or just fine-tuning? You need to decide what you want to do. You need to understand the relevant source, quality versus quantity for this data, and the impact that they have on your outcome. The domain relevance, if any of you are doing like a legal or finance, it's really important to be sure that you have a good data for that. Okay, so domain relevance is here really important for you. When you work with domain, like a specific domain, you need high quality data, right? You don't need too much data, because you can find the different ways of, instead of building a model, you can do fine tuning or RAG or whatever you do. But a small amount of data that you want, it should be good quality data. Now, when it comes to data source, on the other end, you could do text, PDF, website, APIs, and all of these. But you also know that most of the LLMs, we know it's text-based. And you need to also have a proper idea of how to convert the, whatever format, if let's say PDF you have, how would you convert PDF in the text format that LLM expects, right? How many of you have done that? PDF to text. How many of you think you are successful at it? Actual PDF to text. One of the most challenging part of any LLM pipeline, if you work with PDFs, if you actually convert the PDF to text, we're not talking about vision models and stuff like that. Like if you're trying to convert PDF to text, so it can go to your pipeline. Why? Because all the libraries out there, there are really good libraries out there for PDF to text. But as soon as your PDF exits, or basically diverge from a standard definition of PDF, the conversions are pretty bad. Like if you pick a PDF that just starts from text here and normally goes down like a journal PDF, they do a great job. As soon as it becomes multi-column journal PDF that have space between, most of the libraries goes out. They break because the way that they scan. Now, as soon as you have PDFs that are like manual, user manual, with floating objects, none of the libraries. I've been trying that for a long time. They all fail. Because the way that they scan is, PDFs, they have floating objects and this metadata, and they try to use the location as an overlay, like a overlay box locations to reconstruct it for you. But then not every element in the PDF. So the elements on the PDF will have overlapping box. So when those libraries try to work, they mix everything. So if you try to, for example, work with PDFs for your pipeline, that's one of the first things to focus on is that, well, how we convert it. But why is it important? Maybe someone says that I just convert text and that's enough. The reason it's important is that if you have an item, something is written here, and whatever comes here is related to this, is important. But your PDF parser first parses this section, then that comes later. Maybe this doesn't belong to this line, right? So it's kind of like you misled the model or about the data. Even if you try to do simple retrieval, later when you try to retrieve, all you wanted maybe was this part, and you may be retrieving this, and that section maybe is not accurately part of it. So you need to really think about those simple conversions also. Okay, so that's why this data is really important. Quantity versus quality. When it comes to LLM, the idea is that the more data that we have, the more compute. It's like a better quality, which is kind of correct. But how many of you have heard of the chinchilla scaling law? So we had a scaling law, which the idea was that the more data that you have, the more compute that you have, the better the accuracy of LLMs, which is correct. Chinchilla scaling law came up and says that for those models, if you have the better quality data, like smaller models can get basically similar as far as result. Right? So it's kind of like the quality of those models or data is really important. But in general, the idea of with LLM is that the more data, the more compute. There's like a linear relationship with the performance of the models. So synthetic data. If you're trying to build synthetic data, one thing you can do as if you have some API to access is you build your own data. You use some LLM, give some data, and basically try to generate Q&A, basically data for the next task that you have. So you don't need to buy it, but you can also build the Q&A data. Especially with even Llama, you can load the Llama on your model and build the Q&A data. So you have domain data, you prompt it properly, and you build question and answering basically data on that. Now, this is just what we talked about the pre-processing of the PDF and the text format. And these are some libraries that I personally tried. Like I think that these two was, if you're doing a PDF, these two were some of the best libraries that I found. But when I say these are the best libraries I found, is that if you're trying to do engineering work, that means you want to get locations of the elements, and based on that, you want to reconstruct your text format. If you don't want to do that and you just want something to do conversion, one of the libraries is pretty good. It's called Duckling. Right? So Duckling is pretty, I found it pretty useful. It gives a PDF. It does run on PyMyPDF, basically. So Duckling loads that and does the process, but they do all those overlay boxing for you to great extent. But if you want to build your own pipeline, elements, extraction, and stuff like that, that PyMyPDF is pretty good. And it's just an example of that. So I'm just going to skim through this just example for you to see, but LangChain also has support for these PDFs that you can do. It's called oh, they haven't this one. Oh, yeah, this one. LangChain PDF loader that also allows you to do the PDF conversion and so on. So this is that question. All right. Last thing, collecting data and responsible data security, privacy, and fairness. I'm going to skim through this fast because I assume that you all have a good knowledge over this type of things. Data sourcing, that was the first thing we talked about. Be sure you know where this data comes from. Right? Don't source your data from random places. Be sure that you know the owner of the data, validate the data, or it doesn't have poisoning concepts or anything wrong with it. Data security and user privacy, and bias and fairness. Let's make one example. We want to talk about data bias. So you want to build an app that it's just simple image classification. What does that mean? User comes and they upload the photo and it can detect groom and bride and stuff like that. And the data that you have downloaded, let's say you went outsourced Google and you got collected data, works for left, right, and the third one, but when it goes to the last one, it just predicts person triple. Why? Because your data, it's biased to maybe westernized weddings, and it does not understand that maybe in some like other countries, non-westernized countries, maybe their wedding dresses are not the same, or the style of the clothing is different. Right, so that becomes biased. So by default, this different cohort, if they have access to a model, they cannot utilize it. So that's the idea of bias. Now, the problem with data is that data comes from different places. Live data, you build your own, you do web scrapping, open source data, all of those could have inherent bias in those. And it's not that straightforward to detect unless ahead of time, as part of your data collection pipeline, you have validation rules for bias detection. Now, when it comes to data security and privacy, there are some rules that you need to account for, depending on where you're sending the app. The first one, we're going to start with the last one, GDPR. General Data Protection Rules, right? So basically, data protection rule, GDPR, it's a rule, especially in Europe. Okay, so it's like applied across entire Europe. If you build an app and you want to, or platform, you want them to use it in Europe, you need to prove that you are basically aligning with the GDPR. That means you have a data lineage, you have data provenance, you have done all data securities, you remove identifiable information and so on. You also need to give user control over the data. In Europe, if the user requests that to remove my data, you have within a week to prove that you remove all that user data from the entire system. Right? So that's lots of time companies, the startups, they don't want from US, they don't want to go to Europe for these reasons, because you have different channels. Now in California, we don't have GDPR, it's a different law that California has, but it's similar. You need to be able to prove that you eliminate or remove that user's data based on their request. And again, I think I said this before, that's why when you apply for a job, on the bottom asks you if you are from the state of California, because they put you in a different bucket. Okay, so user privacy. When you collect personally or like identifiable information, that means identifiable information has a different definition for different domains. If you work in healthcare, based on HIPAA, identifiable information are 18 elements that you need to protect. These 18 elements starts from name, social security number, MRN, insurance number, anything that could be mapped to identify an entity. When you go to, let's say banking, that's called PII. So in banking, basically, I think that goes about like 11 or 12 elements. So whichever domain you're at, there are some like identifiable information that you need to protect. And that's where you get sued. If someone hacks it and steals it, then you all of a sudden you might get an email that says that we lost your data. That's how the companies get sued, because now you can sue. And actually, there are some interesting policies around this. Like in healthcare, if hospitals only will let you know that you lost your data if the breach that they have reaches a minimum requirement. So let's say, I don't know if, I think Massachusetts is 500. You have a policy that says if you lose more than 500 unique patient data in one incident, you need to go public about it. If not, you can hide it. Now, if that doesn't, it's like a really vague. It doesn't even say that if you do 500, what if I do 500 today, 500 tomorrow, and so on. It says 500 per incident, right? So lots of time you might even lose your data, but you don't even be notified about it. Anyone here using a Park Boston app? Anyone want to park on the street? Yeah. Did you get an email last 2 days? You get $1 for data breach. I got an email that you get $1 as a settlement because they lost so many people's data. $1 per user, and that $1 comes in quarterly 25 cents for 4 times when you park. So they lose all your data, all the sensitive information and everything. You get $1 back. It's really interesting, if you think about it. But there are some rules that you can use to protect this information. One idea is that don't keep really sensitive information if it's not necessary. Maybe aggregate things, right? Maybe location is not important. I just aggregate how many people I know in this area. I should just aggregate certain things. Redaction is that you basically remove some elements or like a PIIs from the data. So that way it's not a full picture. You don't exactly know who's the person, but that's also is really important to remember because some names, even if you remove the last name, the first name is easily identifiable. My name is pretty unique, I know it. If you remove the last name, the first name Ramin, you will find it. You exactly know who's that person. In US, it's pretty rare. So doesn't matter. You need to account for it. Even if you try to eliminate something, you say, oh, I will, the picture is not complete for a certain demographic, that still won't work. So you need to just account for this. Now, how ML system can fail users? First, you want your ML system to be fair, accountable, transparent, and explainable. But the first problem that you can get with ML system is called representational harm. Representational harm is a scenario when your model amplifies a negative stereotype about a certain group. That's representational harm. Opportunity denial is a scenario that your model rejects. Let's think about the admission to university. It rejects certain demographic more than the other ones. Right? Opportunity denial. Disproportionate product failure, and that's where scenario that certain groups gets a lower benefit. Like maybe you're doing an ad, your ad gets promoted less often in compared to other companies' ads by random because the algorithm somehow picks the other one for promotion more. And the last one, harm by disadvantage, and that's where your model for a certain demographic is this basically is associate them with some disadvantage based on some other people. It's kind of your model says that, okay, this person did this crime, so this other person will do this crime because they are similar. It's kind of like harm by disadvantage. So these are different ways, and there are actually more to this, but these are like important ones that ML models can fail people. And lots of these are technically silent. That means you don't notice it, your user might not notice it, but over time, finally, someone will notice, and that's where you get in trouble. Okay, so you want to be sure that you account for these sorts of things. Now, anyone here can tell me, how would you, let's say you have a model built, how would you test your model to see if any of these issues happens? Like I'm not talking about libraries, like expensive code. Simple idea. You have a model and you have your data. How would you test your model to see it works for everybody? Let me give a bigger picture. So let's say you have a model that on average, 99% of the time works perfect. Okay. 99% of time, this model works perfectly. What would you do about that model in order to see if any of these issues happens? This is on minority data. What else?
So the big, the 1%. No.
There is a term called data slicing. Okay, so data slicing basically, as your friends say here, is that not just for that 1%. Data slicing says that you have a data model, 99% of the time it works, but that's on average. You could have a majority group that brings that 99% up. So what you do as part of data slicing, and these are like your decision. One slice could be gender-based, male versus female. One slice could be age-based. You could even create a combination, gender and different age categories. So you slice your data, same data, you just build different code. A good model is a model that works the same across different slices, different categories. Most of the time, what you will see is that your model works really good for the data that the majority of the data, that part of your data that has the biggest group, like from patient perspective, a student perspective, and it's not working well for the rest of the slices. If you have issues like that, you can't say my model is perfect. Like you can't say my model will work for. You could simply say that, oh, for this cohort, we are going to do maybe second, pass the data to a second model, or we're going to do a different thing, or even simply say that this model is not fit for this cohort, have an announcement, but it's only at the moment our model only serves the following code. So data slicing is one of those ways that you can figure out the issues in your model, okay, ahead of time. Okay, almost done. Commit to fairness. Be sure that your model is fair. It's always, just it doesn't have bias towards certain people. And again, this means that this idea of slice your data, do the comparison, and so on. Bias in data representation. You could have data that comes from that corner on the left, but you are trying to sell the app to everyone across the world. So that's the bias in the data, and your model hasn't seen the other cohort. It doesn't understand the data. So, but you are selling it. Okay. I think the last slide is about labelers. So you will hear the basically term raters or labelers, but raters is more common, are the group that you hire to do tasks for you, the labeling. Raters could be generalists. You do crowdsource, could be subject matter experts, people that with the domain knowledge, and could be your users, the people that you're using your app and they give you labels. The last one, which is your users, is technically the perfect labels that you can collect, but most of the time, users, they don't give you that label, right? Because it's just the process change. They're not going to give that feedback. If you can collect it, that's perfect. Most of the time is a wish, it doesn't happen. All right, we're gonna take a break. We have a lab on building an airflow data pipeline. So, but let's take a short break and continue from there.
That's exactly what we're talking
Isn't it awkward? Yes. So. Yeah, you can say different players and what everything you take on. They come and there's no super soon that meeting. So that will put users. Yeah. Oh, you wait, we just. So. Yeah, but if I say no audit, if I do one audit and later I say no audit. Why do you need a? What do you get? You get credit? अपने जान पहचान वाला कोई भी है आते ही It was just like he was couldn't find it. And we were trying our best, but we couldn't find it. Research, and then we came up with an idea. There is no funding. Why do we put it on? People are facing trouble. Just like if you said, oh, yeah. Singularly, conducting and come to our again, we bring no funding. Where people can look at the problems and they can work on and start a solution. This college that I find. They have to figure out like a small part, description of the. It is not right. Here just run out. Use let's say LLMs to reduce out the whole problem and delete the users. What's that? Let's create the whole thing. It's similar to solution. Already exists. We need to use it, which is not use it. If not, then we're gonna yeah.
Where we will be clustering all the following, or maybe that's not there, that you put that as a.
Yeah, like with core it doesn't like documenting the it's not the user and then like the really good of okay, this is how we're gonna do. And it's like like people can afford, okay, I'm working on the service, so let's say 500 people are working like on cancellation. So that's something like and it's really like really good community, but the data what they apply in those that's the data we already has so many cases where people can get data so many I think that's the same. But the website is number one, and number two is the users that they are filling out the forms in the regulations. So showing what it is, it's how we're going to finish the video. My question is, this is a good way to have these. Actually, yeah. Someone wants to do this. There's somebody an idea. You're like, I have this idea. Has someone else built one? So you need to figure out what are the steps any program that you go through in deciding what to make. So you have to simple problem. Answer wheels. Something else built information about that. And then you basically like a new marketing. So how it's understood, one of them is called SWOT analysis. It's the is that you need to not sure that but definitely the beautiful platform anyway for starting. So our vision is slightly different. So what we has been for start builders, but it's considerably for scale. So it's really so you want to say that if you suppose you can Our vision is just making an idea, so that our users can have the solution to that problem. We wanted like, of course, that's what they'll get better. Yeah. The part of user get battles is because I thought what you saying is that user can ask a question was idea that they have and you help them with it. Right. So I don't get what's the other places. So for a project, it makes a couple of these things. So on this, you always start user asks a question. How do we have service? Like the unified. That's the very first thing.
Yeah, but you know, if you can show them like other things that you can use. Yes.
So it's not just so business idea is that always been to our eyes and deep learning they were not even that doesn't exist so I guess really what companies right now I don't know what gives them this build up the brain of project you just you can always have it for now. Still, I mean, yes, you have a question people need to now is what's the point? Where so you can collaborate but the one phase when you build it, you have a forum to post these stuff like that. Focus on what's if you have what's your community, focus on that.
So again, question.
You need to next user question. What's user content? And I break it down for answering this. I need to answer those questions. Answer those. Make values. Particular ideas also so yeah, when you put on the API, it will be different.
I mean, if you need to have an idea. From.
No. This. Because it's all complete, and it's everything was something that was from 10 to 100. Spreading out
Some of them are and he wants the level that.
I also. I told you that.
Yeah, just say that, yeah.
I'm really talk about it. I mean, I can figure that out. There's way too many components. Existing. Something on the if you have an idea, like, if that was someone's idea, like, we how to start it from, yeah, that's it. I did not have. It's like for other dates. Yes, so today, the groups were not here. Just like. The next one I do is that. Like this ask him to see this. So I hope you read. I plan for someone ask things to you. I just. But. If like, we have done that today, it's gonna like somebody. So I know what the but the comment was this. I'll ask with you, don't need all this part of the data. Yeah. This specific. You know there are two members that did it. Last question. I have 5 minutes and they ask another 3 questions. That doesn't really support that. Because the TIS is here before. That's all you get. Great question. It was more. We need it. So can we do it after the class? All the questions after the class. Okay, everyone.
All right. Okay, so for today's lab, we want to work with airflow. Let me see if this. Okay. Now, I did mention that airflow is one of those orchestration tools. And especially is useful when you want to work with something like a DAG, right, which is directed acyclic graph. Now, on your repo, there are airflow labs. There are 3 labs, which I'm going to do 1 and 2, and the third one is for you. The version of the Docker file that's Docker Compose is on the repo is Docker. Yeah, the version is Docker 2 point something. The version that I'm using right now is Docker 3.1. So the only difference is that the Airflow dashboard has changed, but I'm going to push this code to the repo in case you want to use the new version, basically. Okay. So when you want to when you want to work with Docker, this Docker Compose, how many of you have worked with Docker before? In case you haven't worked also, that's fine, but we will have labs on Docker. But you can think about as like this idea of containerization is that when you have a code or a piece of software and you want to give it everybody and you want it to work for everybody instead of they don't need to worry about dependencies issues and stuff like that, you containerize it as a Docker file and you give them the Docker file, and when they run that, basically when they start the Docker file as a container, it basically gets rid of all the dependencies issues that they have. They don't need to worry about I need to install something or not. We will have labs on Docker later. Docker Compose, on the other end, the file that you will see, and this file typically comes from Airflow website. Docker Compose is that when you have multiple services that you want to expose, instead of individual Docker file, you compose them together into a Docker Compose. So within this Docker Compose file from Airflow, basically there are certain information that you need to set. So here, basically, this is for the Airflow 3.1. If you go to, if you go to the one that you have, which is Airflow 2.1, some of these fields, they don't exist. So Airflow 3.1 has done some changes, but doesn't matter. So there are some features here for you to basically think about, like this executor. This is celery executor. You don't need to change it. Airflow has different executor that you can use. By default, I always use the celery. So just utilize that. It basically works with Airflow. Basically has some authentication manager in case you and your team you want to use Airflow and you need to use it to authenticate and stuff like that. It has a database which is by default right now on Postgres, so it's great. You can also change it if you have your own database. You need to basically change the address. It has this Fernet key, API key. Those are new for 3.1. It didn't exist in the previous version. The new Airflow exposes an API for API call. Previous version didn't have that. And then here, Airflow core load examples. Be sure to set that to false instead of true. Because when you set it on true, when the dashboard comes up, it brings hundreds of examples. It's really messy and it's hard for you to find your own work. If you set it false, every time the airflow comes up, it doesn't load any examples for you. But if you want to practice with the examples, set it to true, basically. So then here, as you go down, this part. Sorry, this one, you see, airflow scheduler enable health check, true. That health check allows airflow to do a health check on the system, and it gives you it as part of like a dashboard, so you can see the health features. You can set it true or false. Always, most of these platforms these days, they offer you a system health check. Utilize it. You don't need to write your own, basically. Then here you see on the line 74, PIP additional requirement. So that's the part that when you try to run you're building a DAG, which that DAG is your entire pipeline, let's say, for your data processing. Let's just focus on the data. As part of this DAG, so you have Python codes. We're going to see this Python, but there are libraries that you use. Pandas, NumPy, I don't know, whatever you're using, scikit-learn and stuff. So you need to add them here in the pip additional requirement. So what happens here is that when this Docker compose file basically starts, it will install those apps as part of the container environment, container runtime. So otherwise, if you don't add the libraries there, when you run your DAG, you get error that these packages, they don't exist. So any package that you need to run with your code, you add it here in front of this as part of the pip install. So here, line 74, in front of it, I put pandas need scikit-learn. Those three libraries additional to default Python will be used. Then you go down here, there's a volume. So these volumes are pretty important by Airflow. It needs those to basically be on your machine, on the folder that Airflow is accessing. One of them is project directory DAGs. DAGs is where, so DAG was what directed acyclic graph is where your actual code basically is. That's the actual code. So you need a folder here called DAGs. Okay. And in the new version of the Airflow, basically they tell you after colon you put Z, because sometimes when you build folders, they need a different permission. Airflow is not able to access the permission. In the new version, based on the documentation, is if you put the Z, it basically changed the permission for the folder, so you don't get errors on the permission. In the previous versions, that Z doesn't exist. You see that letter Z. They don't exist. You need to manually give permission to folders for the Airflow to access. But in the 3.1, that's optional. Then you need a logs folder, a folder for writing the logs to. You need a folder for config file. So Airflow creates a config basically file also. You need a folder for plugins, folder for working data. You either have those, or you create those as soon as you start a project as an empty and you write to it, basically, depending on what you are doing. And then there's this UUID for Airflow. So basically, you define a unique user ID. Then, here there are some variables. Your Airflow will depend on, these are the Airflow common dependencies. Redis and Postgres. This should too, yes.
So I was looking at the lab and there was output directly also, but here you are not included that twice. So
I just didn't add it. So that's the same thing. I think if you go to second version, the older version. Yes. Oh, sorry, that's the lab 2 or 3. I think that's lab 2 or 3 when we have a model. This is for lab 1. I don't think we have an output directly. In lab 1, we don't have, I think that's lab 2 or 3. We will see. We will have some other problem. So basically, this tells you that when this Docker compose comes up, yes. No, go ahead.
Oh, where's the Docker file?
It's not on. Oh. Okay, so. So here, if we go that just here.
You're showing us?
Oh. Some reason I cannot mirror the monitor. So if you go to Airflow, just search for Airflow 3.1 Docker. And then you get this, that's Docker Compose. Yeah, fetching this Docker Compose YAML. So I just picked it up from there directly, but I think I haven't pushed it to the repo. Yeah. I thought this should be part of the labs, but let me check. Oh, you're right. Oh, actually, it's in the lab. If you go lab 1 through the README, go down on under the tutorial. There's a link to the Docker Compose that we're using. So, anyway, so basically what this says is that if this Docker Compose comes up, it depends on these two services, Redis and Postgres, and these two should be healthy in order for the system to come up. Okay, so you can change that and you can add additional basic depending on what you want to be the dependency. Then here from line 90, no, I didn't want to run it. From line 90 and forward, you see here it says services. Those are the services that exist as part of this Docker Compose, starting with Postgres. First thing you see in your Postgres, it has username, password. There's a default. You can change it. If there's a volume, you see there's a volume where this Postgres writes on it or reads on it. It's just a local on my machine, but maybe you have a database access that you want the Airflow basically access. You have your own Postgres, so you can change it. It has some other parameters. Then you have Redis, same story. Which version of the Redis you want this to run, and some basically parameters over there. This is new, only exists in Airflow 3 and after. Airflow API services, basically it's creates this localhost API that you can request to also. Then when you go down, you have Airflow scheduler. Now, what is a scheduler here? So when you have DAGs, DAG has components. These components need to be, so when you run a DAG, what Airflow scheduler does, it goes over the entire DAG and says that, okay, these components need to run in this order, and it is scheduled, and it creates all those dependencies. So the job of a scheduler is to basically schedule necessary workers to run your code and create the interdependencies between us. Okay. That's your scheduler. Also, this one depends on Airflow init. So that means this only comes up if the Airflow is initiated correctly. The Airflow DAG processor, basically its job is to process the DAG as names comes. This one also depends on service completely successful for Airflow init. That means Airflow init came up, then it will run that. Then you have Airflow worker. And this is basically, it's just the definition of your workers on the Airflow. So you have a health check for it. There was some parameters, maybe. There's some parameters here, but not. Anyway, so it uses this environmental variable. It's always restarting it as soon as you update your DAG. It automatically. So if your Airflow is already running and you change something to save it, it automatically restarts. So you don't need to stop and restart the Airflow. And it also depends on the following dependencies. Then you have a trigger. So Now, what is a trigger? So you have a DAG, which when your airflow comes up, it basically parse it, it schedule it, right? But it doesn't necessarily mean that it will run it. It could create a workers and says that you will do this, but it doesn't run it. So trigger could be that something that happens based on cron job. That's a job of trigger. Trigger could be manual. User need to hit run. Trigger could be based on another code. Like you have a pipeline, totally different DAG, different code. Runs, whenever that one finished, that one goes, triggers another pipeline. So those are all trigger options. We're going to see both of those here now. And then this last one is airflow init, and that's where basically it initiates the airflow when you run basically the compose. All of this is basically fixed like for the moment. You don't need to change. But in case you want to change, this is where you can define the number of CPU cores, RAM, what you want to allocate to your airflow in your local machine. So as you go down, probably you see here, memory available should be, if it's less than 4,000, it basically probably gives you some warning, not enough memory. So you can change that allocation depending on how much you think your pipeline need memory minimum. Number of CPU cores, it's here too, but maybe you have a pipeline that if you have less than 5 cores available, it shouldn't run. Or it should basically, your airflow should give error. So you basically you can change that, those parameters. So these are all depending on what you, how much resource your airflow need or your pipeline basically need. I leave that to you to read through this. So, and then this is the CLI, basically the CLI of the airport. It's nothing most, and this at the end there's a volume, Postgres, DB volume. So that's the volume, and you can also change that. For now, you don't need to change anything. Just download this airflow, basically the Docker Compose. Be sure that you add the necessary pip libraries that you need for it to run. That's, for example, pandas needs scikit-learn. Maybe set this one to false, and then just run this. So if we so first thing I can do is I have this script that before the lab I will run it. So it cleans the slate. So there's nothing on it, no logs and anything, and just runs it basically. So then we can do the lab. So hold on. Cannot see because it's setup one. I'm just getting rid of anything that's in the memory. So what this script does, you'll get this one also. After first, every time I run it, it first cleans that folders that exist, logs, plugins, and config, and recreate an empty folder. Then does basically an airflow, technically an airflow in it, and then it creates this config file. So this config file by default doesn't exist. What it does basically, it goes through the Airflow Docker Compose, extracts those configurable information, and puts it in one file called Airflow config, basically, which Airflow requires that. So it just quickly creates that for you. So that's it, Airflow CFG. So now that is running. So let's talk about what we are trying to do here. So in the lab, you have a folder called DAGs. Every time you want to work with Airflow, you need to have a DAGs. Why? Because when you don't have a DAGs, as Airflow looks and says, okay, I don't find anything to run here. The dashboard could come up, but there is nothing to run.
So you need to have a DAG, and the good thing about Airflow is that it also, when it loads, it verifies and it tells you that how many that DAG I found, if any DAG has an error, that you need to fix it ahead of time before you go run the code. So you can see all of those in one place. So inside the DAG folder, there is a data folder, which is just some random data. There's a model folder, which is the model that will be saved later. There's SRC. Inside this code is just simply supposed to do bare minimum of a code. So it basically has a couple of functions. One is that it loads the data. The other one, it does the data pre-processing. The other one, build and save the model over the pre-processed data. And then the last one is the load model, basically. It's kind of like it's using, you know, the knee analysis, elbow analysis to pick the best model and just load the model. Now, that's part is the only thing important here, the code that could be anything, is that I have 4 components: data load, data pre-processing, model training, model load. Okay. And before working with Airflow, you need to first understand the relationship among these components that you have. You want to build a DAG, right? So as part of this work, the first function that I have, load data, is going to be a node in my DAG. First node. So that means so this is going to be load data. That's the first component. But after that, I have something called data pre-processing, right? But I know this data pre-processing depends on I have a data load. Okay, so this one loads the data, and this data pre-processing as an input gets the data that comes from here. Okay. Then I built a model. Then it's just kind of like a validation. So simple pipeline, 4 components, 4 nodes as part of the DAX. Right? Could be any components that you have. But understanding the relationship, you will say, is important, because when you build a DAG, you need to create the connections. DAG gives you nodes. It's like when you're building a neural network, you build layers. How you connect the layers to each other, which layer fits to the other one, that's the part that it's right. Neural networks are not DAG, because you can have like a different versions, like a different connections. But so here, so that's this code. Again, I'm not going to go over it. The important code is this airflow.py, or you can call it anything. Doesn't need to be airflow.py. But normally, what happens here is that Airflow scans your basically DAG folder for codes. When it scans, after I run it, I will show you. It shows you a table. It says, I found these files, but it tells you which file among those files is a DAG, which file is just a code. The file which is a DAG is the entry point for working. The other ones are helpers techniques. So if a file does not have a DAG, you see, weak DAG, or indication that this is a DAG, it will not be an entry point for you to trigger. Okay, so in order for a file to be a DAG, you need to basically start on top here. From Airflow, import DAG. So you need to build a DAG also in this file. That's how Airflow will pick it for you. So you first import that DAG. There are a couple of imports that you did. The important thing for Airflow is that Airflow is pretty strong in industry, because they have built connectors for almost everything. So one of the good things about this is that it has all sorts of providers. One of them is Python. It has a Bash, Python, I think Java, and it also has like same operator for AWS, GCP. So it has all those connections. So, but because the code that we are going to run is Python, you need to from Airflow providers, standard operator in Python, import Python operator. Okay, so let me close this. Okay, Python operator. The next version is bash operator. Everything has an operator at the end, so you know this is the operator. The work of an operator is the piece that's responsible for running that code for you, that component, that function. So Python operator is an operator that's responsible for running Python code. You need that. Then I'm importing those 4 functions that we have built from SRC, nothing else. Right? So basically we imported a DAG, we imported a Python operator. And there's a data time and time delta just for other things. Now, there are a couple of differences. If you work with Airflow before 3, in order to transfer data among nodes, you have basically multiple options. One option is that you save this to a local drive after the step is done, and the other one basically reads it. Like kind of like a separate from each other. One option is that you kind of pickle this data to pass it to the next one. Airflow using a version of pickle called XCOM. So here, XCOM pickling. So Airflow uses that. So basically, it's kind of like a serializing and deserializing data in order to transfer between nodes. In Airflow 3.1, they have changed it. It's like they made it a little more, I think, a little more challenging because now the data need to be in a proper binary and then JSON format. Previously, you could just pickle it and pass it. So anything before 3, you can just pickle and using this XCOM transfer. In this new version, 3.1, you will see in the close the other code. I will show you later. I kind of changed the code to binary and then convert it back again to pickle. So I have a pickle, but in order to pass it, you need to convert it to a binary. And then in the next function, you need to first convert the binary to pickle and then unpickle. So it's kind of like the process becomes longer, but doesn't matter. So then there is this default arguments. Those are like some arguments that you want to define as a default for this DAG. What's the name? Who's owning it? What's the start date? How many retries do you want if a DAG failed? Right? You could add numbers, or maybe because you're at first trying, just put 0. I don't want it to be on a loop. Maybe I want to know if it's something failed. And the retry delay basically says that if I'm about to retry after failing, how much should I wait? Because sometimes resources are, kind of like exhausted, or resources are kind of like booked for something else. Maybe you need to have a delay before you restart. So that's the default arguments. Now, the main problem basically starts from here. Okay. There are kind of like different ways that you can define DAGs. One is that you can build a basically file, probably here. If I go to, I'm going to share the screen so you can see. In the version that you have access to, probably, if I go to DAGs, which is the previous version, you see, I'm building a variable called DAG, which is an instance of the DAG. Does that make sense? And then I pass that to every operator. I say that this is the DAG that you belong to. So you can think of it like this. You have an empty canvas, this canvas called DAG, and you build functions separate places. What you do, every function, later when you pass it to an operator, you say this belongs to that DAG. Let's call this DAG A. This belongs to A. This belongs to A. Kind of like a mapping. All right, so that's this version. In the new version that you see right now in the lab, which is technically the same thing, instead of creating a DAG, I'm basically opening a DAG and put everything in it with DAG basically. Okay, so they are technically the same thing. One, you create an instance and connect it. The other one, I open a canvas and I put the components in the canvas directly. So this version, I have a canvas and I'm just basically starting putting data processing here, then putting this one, and this all four here. Now, whenever you build DAG, you build the components first, you're writing the code. There is no connection between components here. They just know that they belong to this DAG. That interdependencies among components comes later. For now, it's just a code that you just adding. So we build a DAG. You always need to give the DAG a name. Why? Because it's searchable. You have sometimes lots of components and you want to search through it or do a query or compare runs. So that Airflow lab one is searchable. So you normally need to pick something unique for yourself. Default arguments, I'm connecting it to those default arguments that I defined up there. You give it a description. So that way, if you have multiple, you can quickly see where it comes from. Catch up false, just I don't want it to catch up, just do it false, so you can see. Now, this four we want to define. Okay. So what you need to do is that I have the code and I import it. But I want to load this code as a Python operator. Every time when you have a piece of component that need to run, you need to use some operator. Python, again, Bash, Java, sorry, what's called Cloud Function, Cloud Runs, all of those, they have their own operators basically. And Airflow has the service for all of them. So let's start with this task, load data. So it's a Python operator. I give it a task ID. Then you basically say, what is the function related to that? Python callable, load data. So this is defined. Now, this is an basically node in the DAG. Okay. It hasn't been connected to the other one. It's just defined as a node. Previously, it was just imported. Then data pre-processing task. So this is also a Python operator. You give it a task ID and what's the code that you want to call. But here, you know the connections. You knew this only can run if this data is ready. And this function has an argument as an input, Python function. So the argument, operation arguments, becomes the output of this one. You see, load data task dot output. So by default, the output of this one becomes the input to this one. Right? Then build and save the model. Same thing. That's going to be I cannot see the mouse. Oh. It's going to be a Python operator. Give it a name. However, this function had two arguments as an input because it saves the model. So it needs the data from previous step, also a string name for saving the model. So the operation argument becomes the data from the output from previous step and model.save as just a string. Yes.
Just like LangChain, can we do parallel processing, like parallel chains?
Yes, you did. We will talk about it. So far, we're just defining those. We haven't execute and defined how to execute things, basically. It's kind of like you build nodes and then later you parallelize. Then here, the next one for the last step, Python operator, and it needs the model name because it wants to load the model name. And it needs the output from this one, which is the result of the model because it's going to do elbow to select the top model, for example. Anyway, so these are like a four nodes. Now we want to create these dependencies. And in order to do dependencies, the chain rule in the DAG is this one in Airflow. And this is really similar if you have worked with R language. R also uses, I think it's the other way, then something like that, right? So, but it's basically stands for this chain rule. So this passes to the next one and so on. So load data first runs the dependency, then the other one runs, then build model runs, and then load model, right? So we build this DAG now, and then at the bottom we just basically you define it either CLI or a test basically. Now, if we run this. So Docker compose up, and I'm going to pull this up so we can. Takes a couple of minutes to normally come on. You see, add all those permissions, and those Z parameters basically does all those permission things for you. And yeah, it changes the basic ownership or basically the access to those files, those folders. So here you see it basically found. So far not actually. It will be I think second or the first time we didn't find anything. The next one I think is we'll find one DAG and one code because it's still installing. So you see what it does, it's installing the whatever is necessary on the worker number one. So if you have multiple workers, we kind of make the replicas of those ones. Okay, so now file processing state. So here you see it says I found one file, airflow.py, which is a DAG, and it didn't find any errors basically. So now it tells you that okay, it's found, it's ready. So if we go to somewhere here also, sorry, I can see somewhere here. We also have a link to the UI. Maybe. Yeah. UV coin. And because by default the Airflow was username password Airflow. So when you say so this is the dashboard. This is technically dashboard 3.3, it looks like it. 2 does look completely different. So what you will basically starting from this page on top shows you failed DAGs. Sometimes you can open the Airflow, but you don't see any code that you can run. But then you see the failed DAGs, the red, it has numbers. That means, and it tells you what are the errors it found in your DAG and why it cannot run it, basically. And then running, if you have anything, it will show you. If there's anything active, it will show you. There's some other additional information here. We don't need that at the moment. Here under the DAGs, it shows me there is one DAG, Airflow Lab 1, and that's the name was we added to the DAG instance. So if you go click on your DAG, on here it shows those components, those nodes in the DAG. You can see it that way. You can basically like a visualize it differently. If you click on one, it basically can give you additional information about that. It's a Python operator. Trigger rule should be all success before it goes to the next one. Nothing else here, and so on. So let's go one back. Sorry. So here you have some stats chart. These are again those components. If there's a schedule or basically summary of the weeks, the code it will be shown here. So you don't need to go back to your code to look. If you want to quickly look, you can see the code here. If there is any basically variable, something like that, like a configuration. It also shows those here. Now, let's go back here. So if I say run, so what you see here, this one, you can set it to true or false. If it's on true, it automatically triggers. If there's a DAG and it's ready, it basically runs it. And then if you hit this one, play, it basically says that, okay, do you want it to be a single run DAG, or do you want to do a backfill? That means if you could say that, oh, I want to run it from that date forward. That's the definition of backfill. Sometimes maybe you have a pipeline that broke and it didn't run for 3-4 days, and you want to run it for 4 days ago. So that's the backfill. But because you say, I want to run it from now, I'm just going to say trigger. And then I can go here. So this is running. So it basically tells you also. Yeah, you see the green means done. Blue means it's basically running or it's queue, and then if it's red, basically, and it's kind of the older version had this really good also color coding on top. This version I still don't know where it is, but basically this says it's done. So now if you click on a run like this one, you can get information. You can get basically this is called a Gantt chart, right? So Gantt chart is a way basically for you to understand your pipeline and efficiency of components. What it tells me, for example, is that the load task and the build the model, they're taking the load data and build the model, they have the highest basically load. They take the most time. Right? So maybe those are the part that you could optimize. So when you build your pipeline, look at your Gantt chart and understand which part of this pipeline I can optimize. Maybe the load data, maybe I don't need to load the data at once because it takes a large time. Maybe I load it slowly, like a streaming, right? Or you need to basically figure out which components in the data pipeline is inefficient and basically work on efficiency of that. The next thing is that so you can basically pick a component. And then you can go logs. If you have logs or something happens you want to see, you can see all the logs that you have added to your code. Render templates, XCOM, that's the part you see that when you transfer data between components, that pickling concept. That's that one. Access event, audit log, code, and details, and so on. So all of those basically we have for this one we only have one DAG, so it will be here. Then you have, let's see the assets we don't have here right now. Browse. I think this is not free. Basically, maybe you know this one is free. That's all your XCOMs, audit logs, required action. We don't have anything. That's sorry. Variables, pools. Okay. So this part, if you go to variables, you know when similar to GitHub, when you have secret variables and you need certain environmental variables, you can also define them here. So instead of having an environmental file, maybe you can just in your Airflow go and you can either import variables or you can just say, I want to add a variable. What's the key value? And basically it reads it from here. Yes.
So where do we use these variables? Is it like used in the workflows which we just made?
Yeah, think about it like you make an LLM call, you need the API key.
All right.
And you don't want to basically cook it to your code. Or maybe you don't even want to have it as part of your environment because other engineers are not supposed to see it. So you as a manager, because you will have a different access to Airflow. You go to Airflow and you create this environmental variables. Your engineer, your team code can call to them. but they cannot see the variable.
Alright.
Alright, so basically you just go with this. Environmental variables could be something that's shared, everyone can see, could be something like a secret that you don't want anyone to see. Then we have this admin, there's pools. Pools also is what for the workers that you want to define. So here I have default pool. Basically, I have 128 slots available. I don't know, but you can basically change that number. Sorry, I can't see this properly. Providers, plugins, connections, configs. Series of these are when you go, you cannot technically change. I think you need to have license and stuff like that. But if you go to user, here is where you can define when you can define also different types of user. Maybe one of you wants to be a manager for the Airflow and give access to everyone else and stuff like that. So that's where you can be. And you can define different permissions, like someone can access this, someone cannot access the other one, and so on. So that was the first example. Any question before we go to the second one?
How do we trigger the tag based on any other events?
Going to do the second one. All right, so let me stop this. Okay, so your friend basically asked an interesting question. Okay, how could we trigger the DAG based on other events? I'm going to go over this one quicker because we did the first one. So the goal of this second lab is to do two additional things. One, I have a DAG that runs. Whenever this DAG runs, it's supposed to go find another DAG in the inventory and start that DAG. Okay, so like that's how they're working together. The second thing I wanted to do is whenever the DAG is finished and is successful, I wanted to send the email or a Slack to me and says that I'm done or there's an issue, kind of like a notification. Okay, so in the we can't define it, sorry. So in the Docker Compose, go to this one. In the Docker Compose, there are a couple of things that you need to add in order to make your Airflow just give me one second. I'm going to switch. Yes, and then I go back to that one. Because much easier for me. All right, so let's go here. Let's go to labs. No problem. No. Back to the square one. Okay, so this section is added to the Docker Compose. It doesn't exist by default, you need to add. And basically it tells that Airflow, you need to make an SMTP basically connection. Gmail, for example, uses SMTP. Like if you have an app and you want to allow the app to connect to the Gmail, you need to go on your Gmail, create an app password. So if you search on Google how to create Gmail app password, it goes to your username password, your Gmail, you create one API key, which is secret. Don't give it to anybody. This is your API key, and you add it to your Airflow. How does that work? So Airflow, Airflow doesn't have an email system. So in order to send you an email about a notification, it technically logs into your Gmail, send the email to yourself. So it doesn't read or write, it doesn't read, it just basically logs in like it has an app password, send the email to yourself, and that's it. So it's private, read about it, but you know, it's just a SMTP password. So you need to create an SMTP, it's Gmail. These are all fixed. Here you put your email address, here you put username, it's the same as email address. And here is the password that you're going to get from Gmail when you build an app password, app access, basically. Okay. The rest of the things basically is the same. This is the same Docker Compose. Now, the difference on the second lab is we have one airflow.py, one lab.py. So let's start with the airflow.py. So here on top, is it the same one? Sorry, we have main.py and we have flask.py. So in main.py, let's start with that one. So these are the components that we need to work with. I need a bash operator, and the only reason I have it here is that to show you you can run a bash code. There's a bash operator, there's a Python operator, there's an email operator to send the email for you. There is a trigger DAG run operator, and that's where you can trigger other DAGs by an operator. Okay. And then the last one you see from Airflow task trigger rule, import trigger rule. When you want to use Airflow to trigger other DAGs, you need to define rules. What should be the rule in order for me to trigger? All done, all success, all complete, and so on, stuff like that. So you might want to say that I only trigger the next DAG if everything was successfully done, right? You might say that I don't care if something also failed. Anyway, I will run the other DAG. So you decide on those trigger rules. And then the rest of the code that you see I'm importing is just some Python code for the example. So here, basically, we create a DAG. Now, there are a couple of new parameters just for seeing. Description, schedule, daily. So this means that this DAG automatically every 24 hours will run without a need to user to go basically trigger it. Catch or false, I give you the tags. The reason for tags is also, again, as an example, on the dashboard, you can query by tags. Maybe you have a different DAGs, but they all belong to the same project. So the tag becomes the project or the, like a, I don't know, like a domain that they belong to for later query. Owner link, you can ask information about the owner, which engineer is working on the DAG and stuff like that. It's just an example for you to see. Max active runs, I set this to 1 because I wanted to ensure that the model, if there is anything in the background running, doesn't start the next one. It waits for the other one to complete and then it starts. Max active run. So then bash operator is an example. I'm just creating a bash operator which is supposed to add the owner Rami Mohammadi basically on the DAG on the dashboard, just to show you that it can do an echo also. Email operator, basically, I create a task ID is going to be named send email. This is the email that you want to send to, and this is the text that I wanted to send as an email. And it doesn't need password and stuff like that because those are all part of the Docker Compose, right? So you basically run that. Then you build a Python operator for load data pre-processing, which just gets the data input from the previous step. Basically separate the data, build the model. These are all Python operators. And then, so there are the kind of, here we have 5 Python functions. And then we have this one, trigger DAG run operator. This is the one that goes, finds another DAGs in the inventory and executes that DAG. So you basically say that I give the task ID, and it's going to trigger any DAG ID that has the following ID. So it will search through the inventory. Wherever it finds a DAG with that ID, Airflow Lab 2 Flask, it will trigger that upon all the rules complete. Okay. And reset DAG run false. There's a message if you want to show wait for completion false. Wait for completion means that the current DAG at this stage, goes runs another DAG. Should this DAG, the current DAG, check itself as I'm done, or should it wait for the other one to complete before it says I'm done? So when you say false, that means don't wait for the other one, just say I'm done. You release the the resources that you have. Trigger rule all done. That means everything should become like a done in order to trigger the next one. So does that make sense? And then you basically create the dependencies the way that you want. And at the end, I say that load model tasks. So this will automatically, after it's run, is finished, opens this Flask version. Okay. Now, I'm not going to go over the Flask version. I will leave this for maybe next class we just complete it. But what I'm doing in the Flask version, I want you to read it and think about it. The Flask version is it's just going to be a Flask API, that's dashboard. The idea of this dashboard is when it wants to come up, I want it to be dynamic. I want this to have different pages that could load. One page as an HTML says all successful, blah blah blah, whatever you want. Another page that something failed, engineer research, pay attention to what. But how it should decide, what I want this to do is that when this DAG get triggered, it will go back into a DAG run history search, and it says that basically this is this function that you see. It gets the status of the previous DAG. Everything was successful, not everything was done. Was everything successful? Was there any issue and stuff like that? Based on that, it creates basically it reroutes the main page of the Flask either to here or to here. So think about this. You have a pipeline, you're an engineer, every morning you open your dashboard, you want it to, if there is an error to be take you to that page that you need to pay attention. If there's no error, just takes you to a page that everything is good. So this is what it does. Then here, this is the general index. This, when the Flask API comes up, this is the main page. It gets the previous info from the previous run. Based on that, it reroutes you either to a success page or to a failure page. It also has a health page that you can check. Then there will be a general Python function to start a Flask. And now, the only thing I need to do is that build a DAG for this file in order to be detected as a DAG. Give it the DAG ID name, the ID name that the previous DAG will search for in order to trigger. So I give it a name, one couple of basically parameters similar to the other one. I'm creating one Python operator to start the Flask API, and then that's it, nothing else. Start Flask API. So what it does, when it comes up, it runs the other one. When it comes up, when the other one is all done, triggers this one. This one, when it comes up, when you open the like a page, like the web page that you have, it automatically dynamically decides which page it should take you or not. Okay, so we can leave this and run it in the next slide, just because I know everyone's falling asleep. So that's the idea.